Hello Cloud Gurus, my name is Warner Chavez and welcome to my Managing Azure SQL Database for the SQL Server DBA course. I'm a Microsoft Data Platform MVP and Solutions Architect at Pythian with over 15 years of experience in the industry, many of which I spent as a SQL Server DBA as well. In this course, we will begin by introducing Azure SQL Database, the main characteristics of the service, its value proposition, and creating your first database. Next, we will look at connecting to the service, the different network and firewall configurations available, as well as the different ways to authenticate your user account. Next, we will do a deep dive into the service models and tiers, including the DTU model versus the vCore model, serverless versus provisioned resources, the hyperscale model, and elastic pools. We will also cover the backups, high availability, and disaster recovery options in the service, including global replication with auto failover groups, as well as tools and methodology to execute your migration from SQL Server. Finally, we will discuss monitoring and tuning Azure SQL Database, including the tracking of metrics, creation of alerts, and performance troubleshooting with portal tools. By the end of this course, you will understand the main concepts, behaviors, and tools of Azure SQL Database, so you can take on any project that uses this exciting Microsoft Cloud database platform. To follow along, you should have basic familiarity with database administration. Basic experience with SQL Server and Azure is not required, but will make it easier to follow along. Join me on this journey as we take your SQL Server skills to the cloud with the Managing Azure SQL Database for the SQL Server DBA course. I'll see you there. Hello Cloud Gurus, a quick word here on the prerequisites for the course. For the student, basic database administration experience is assumed, so you should know the basics and fundamentals of IT security, database management, and common concepts like high availability, disaster recovery, backups, and so on. A specific SQL Server experience is definitely a plus, and the course is definitely targeted to SQL Server DBAs, so if you're in this group, then this is the perfect course for you. Basic Azure experience is also a plus, so you can follow along easier, but is not required either. In terms of the demo environment that we're going to use, the prerequisites are to have a Microsoft Azure account so that you can consume some of Azure SQL Database. You also need a SQL Server instance if you want to follow along on the demos to migrate to and from SQL Server. And you'll need a Windows environment to follow along on some of the demos that use Windows-only tools like SQL Server Management Studio or the Microsoft Data Migration Assistant. Let's jump into our first section. Up next, we will answer the very important question, what is Azure SQL Database? See you there. Hello Cloud Gurus and welcome. This is your introduction to what is Azure SQL Database. Let's look at the breakdown for this section. First lesson is going to be what is Azure SQL Database. We'll learn all the fundamentals about the service. Second lesson is going to be service cost and value. We'll look at the value proposition and the billing model of Azure SQL Database. We're going to look at getting started. How do you create your very first Azure SQL Database? We will be doing a demo of creating an Azure SQL Database, both with the Azure portal and with PowerShell, and we will be doing a chapter summary. Some examples of the things that we will cover in the chapter include, what is database as a service? What does that even mean? We will look at your responsibilities as a DBA when you're running Azure SQL Database versus running SQL Server. We're going to be looking at the billing model of Azure SQL Database. We're going to create your first Azure SQL Database and much more. So, are you ready? Let's go! Hello Cloud Gurus and welcome to what is Azure SQL Database. In this lesson, we are going to cover the service definition of Azure SQL Database. We are going to look at the definition of database as a service. We are going to talk about the different features of database as a service products. We are going to also look at other Azure SQL services besides Azure SQL Database. And finally, we are going to do a lesson summary. So let's get to it. So what is Azure SQL Database? Let's answer that question. Azure SQL Database is a database as a service offering inside Microsoft's cloud computing platform, Azure. So obviously that begs the question, so then what is database as a service? Well, I'm glad you asked. Database as a service is a public cloud offering where the cloud provider does most of the administrative and infrastructure duties of operating and maintaining a database. And Azure SQL Database is exactly that type of offering. Here are the features that characterize a database as a service product. First, the provider will do a lot of the management of all the underlying components of the database infrastructure, such as the operating system, hypervisors, and hardware. Second, you will pay for your usage of the database itself, and there are different models of consumption and purchasing, and we will look at that in detail later on in this section. And we also usually find that there's elastic resources in database as a service products so that you can scale up or scale down depending on your needs. So what can we expect in terms of provider management? In the case of Azure SQL Database, Microsoft will take care of the following. They will take care of the database software, so you don't have to patch anything yourself. They will take care of common database administration tasks, such as taking backups. They will take care of the underlying components like the operating system and hypervisors. And of course, they will maintain and take care of the actual physical hardware. In terms of pay for usage, the service users will pay according to their usage of the service. You won't have an upfront expense or contract lock-in unless you want it, and you may want it if you want to get some sort of discounted rate if you contract for longer periods of time. Finally, you'll have elastic resources on demand. You will be able to scale up or down and create or destroy environments whenever you feel like it, with no provider intervention. Azure SQL Database is a child of SQL Server, born for the cloud. It is based off SQL Server's proven database code foundation, and this is a great opportunity for SQL Server DBAs to put this new product under their tool belt. Now, when you start using Azure, you will run into other ways to run SQL databases. You might be thinking how they compare to Azure SQL Database. The Azure SQL Managed Instance groups multiple databases into an instance, very similar to how SQL Server does it on premises. So it doesn't have a single database model. The intent is to have less isolation and to mimic more closely how you deploy SQL Server on premises. Another way is to simply run Azure SQL Server virtual machines. And of course, this runs the full SQL Server software, but you have the responsibility of the software and the operating system of the virtual machine yourself. In Azure SQL Managed Instance, you have shared resources. There is instance level management, so HA or DR, for example, will be at the instance level. There is less isolation between database, so three-part queries, for example, will allow you to query one database from the other if you have access to both of them. Azure SQL Server on virtual machines is the full version of the SQL Server software. In this case, of course, because it is a virtual machine, the client is responsible for all the management of SQL Server and the virtual machine operating system as well. And you get partial provider capabilities. So Microsoft does have a few agents that you can deploy if you want to have patching done by the agents or backups done by the agents, but those agents are still under your responsibility and they run just as regular programs in the operating system of the virtual machine. In summary, in this lesson we learn of the Azure SQL Database definition. It is a Microsoft Azure Database as a Service product. We talked about the Database as a Service features, such as management automation, pay as you go when you use the database, and the ability to have elastic resources that you can scale up or down. We also looked at the different Azure SQL services that you might use to deploy SQL databases, such as Azure SQL Managed Instance and SQL Server on Azure Virtual Machines. Thank you for joining me for this lesson, and I'll see you on the next one. Hello, Cloud Gurus, and welcome to our next lesson, Service Cost and Value. In this lesson, we are going to go over the billing model for Azure SQL Database. We're going to look at the different service tier models for the service. We're going to look at the advantages that these models offer you as a user and consumer. And we're going to be doing a lesson summary at the end. There are three cost components of the billing model of Azure SQL Database. You will be charged for the compute that you consume, for the storage, and for the service tier that you select for your database. The service tier of the database determines several different characteristics like the size range, the resource range, so how many cores of memory are available for your database, available features such as in-memory OLTP for example, and recovery characteristics, how much is your backup retention or HI and DR characteristics. Azure SQL Database also offers multiple ways to selecting your service tiers. One of them is called DTUs, Database Transaction Units. The other one is called the vCore or Virtual Core based model. DTUs stand for Database Transaction Units, and these are blended measures of CPU, memory, and I/O resources. It doesn't tell you exactly how many cores, how much memory, or how much I/O you have. It's just a benchmark blended measure. But you always know that higher DTUs equals more resources. There are three DTU-based service tiers: Basic, Standard, and Premium. On the other hand, we have the vCore-based model. The vCore-based model allows you to select the exact amount of vCores, memory, and provision storage. So this is easier to migrate from on-premises, as you can just mimic your on-premises configuration exactly as you need it on your database. And also, the virtual core-based model offers some cost benefits. If you already own SQL Server, there is a program from Microsoft called the Azure Hybrid Benefit to reuse some of those licenses. The vCore-based service tier also has three levels: General Purpose, Business Critical, and Hyperscale. We will be taking a closer look at the service tiers later in the course, including what you get with each one of them. The other cost component is the compute, and the compute capacity determines the amount of CPU and memory resources that are allocated to the database. In the vCore-based service tiers, you have the option of having serverless compute or provisioned compute. When you are doing serverless compute, the service is paid by the second, and the rate is based on the active service tier whenever execution is happening. When you are working with provisioned compute, the service is paid by the hour, and the hourly rate is based on the highest service tier selected during that hour. So you have to wonder, how do you select the proper compute resourcing model? Well, serverless is a good fit if your application is okay with some warm-up time, as the resources won't always be ready. The database will shut down when it's idle, and then it will take a few seconds to come back up online when it gets accessed. So serverless really fits when you have an application with unpredictable needs that might need to scale automatically and use more cores as the load increases. And it's also a good fit if the application has intermittent usage, so it has some peaks of activity followed by a lot of downtime during the day. Provision, on the other hand, is when you need those resources to be ready to go, and you have fixed needs in your application, so you know exactly the amount of vCores that you want, and you have regular usage patterns throughout the day. If you have a business critical 24/7 workload, you should be using the provisioned compute resources model. And keep in mind, if you do want to use serverless, it is only available in the vCore based service tier model. It is not available for the DTU based one. The other cost component are the storage charges. The storage charge is calculated in gigabytes. It includes database data and log storage. It includes also backup storage, so the longer you retain your backups, the higher this charge is going to be. And backup storage also has the option of being locally redundant, so Microsoft will keep copies locally on their data center. Zone redundant, so Microsoft will create copies on the other availability zones inside a region. Or geo-replicated redundant, where Microsoft will keep copies of your backups across multiple faraway Azure regions. These billing and service tier and compute models come with several advantages. You only pay for what you use. There's no underlying maintenance that you have to do for your database resources, your hardware, or your hypervisors. You can scale up or down on demand your resources as well. And it's a cloud-first feature release. That means the new features in the Azure SQL Database engine go to the cloud first, and then later on, Microsoft will add them to the SQL Server product. Because of the nature of the service, it really changes your responsibilities as a DBA. Let's look at this in detail. Let's say you're running SQL Server, physical or in a virtual machine. Then you have to take care of maintaining the hardware, the operating system, hypervisor. You have to patch SQL Server. You have to set up backups. You have to have high availability and disaster recovery plans. You have to manage performance. You have to do change control, make sure that everything's properly configured. And you have to always take care of your database server security. In Azure SQL Database, your responsibilities change quite a bit. You have to choose the right model and tier so that you have the proper initial configuration. Then you have to test the high availability and disaster recovery features. The features are already there for you to take advantage of, but you have to make sure that you understand them and to test your applications with them. You also have to take care of performance. That is still very much your responsibility in the cloud. You have to take care that everything is properly configured and you keep track of changes. And of course, security is still your responsibility, even in the cloud, as a shared responsibility model. In this lesson, we learned that the cost components of Azure SQL Database are compute, storage, and the service tier. Then the service tiers can also be specified through a couple of different models. One of them is the DTU-based model, or Database Transaction Units, which is a blended measure of performance. Or the other one is the vCore-based model, which allows you to pick exactly the amount of cores, memory, and storage that you want for your database. That vCore-based model also allows you to specify compute in terms of serverless or provisioned compute. Finally, we looked at the advantages of these models, providing a lot of cloud service advantages such as scalability and flexibility. You also have less operational responsibility as a DBA, while at the same time still being responsible for security, performance, change control, and making sure that you test the features that are part of the service. Thank you for joining me for this lesson, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, Getting Started. In this lesson, we are going to go over the process of creating a server for your Azure SQL databases. We are going to go over the steps to create a database. We are going to look at the methods of provisioning the databases. And I'm going to point you to the latest service information that you will want to keep track of if you are going to be adopting Azure SQL Database. Finally, we will do a lesson summary. Getting started with Azure SQL Database is pretty simple. You have to create a server, and then after you create a server, you can create a database placed inside that server. A server in Azure SQL Database is a logical entities for grouping databases. For region and connection purposes, it does not match to an actual physical server in the Azure Data Center. Creating a server is pretty simple. You pick a server name, and this server name has to be globally unique. You pick a region, so you have to pick from a region all around the world that Azure has available. And you pick an authentication method for connecting to your server. The authentication method can be Azure Active Directory, It can be SQL authentication, and this is where the usernames and the passwords are managed and saved inside the SQL database. Or it can be the combination of both. As best practice, Azure Active Directory is the preferred method of authentication. Once you have your server set up, then it's time to create your database. You have to pick the server. That's going to be the home of your database. Then you have to pick a name for your database, and this name has to be unique only in the context of the server. And then you have to select your service tier model. You have to decide whether you're going to use the DTU-based model or the vCore-based model to do the service tiering of your database. Remember, once you select either one of these models, then you have the different tiers that you need to select, either basic, standard, or premium for DTU-based, or general purpose, business critical, or hyperscale for the vCore-based. And don't worry about it, later on in the course we are going to go in depth into what you get from each one of these different service tiers. But for now, just know that this is a choice you have to make. The other choice you need to make as well is the compute model, whether you're going to use serverless or provision resources for your database. And remember that this choice is only available in the vCore-based model. More detailed configurations like firewalling or the collation of your database will depend on specific requirements, whether you're migrating a database from on-premises or the application requirements of your net new database. Once you know the configuration you want for your server and your database, you have different ways of provisioning it. One could be through the Azure portal. You go to create resource, and then you can search for SQL database and start the wizard there, and I will show you that in the demo. Another way to do it is through PowerShell. There's the new AZ SQL database commandlet that you can use to provision your database as well, and again we'll see that in the demo. And there's a tsql command as well. If you have admin rights to your Azure server, then you can connect to the master database and issue create database commands. One thing to keep in mind is that in the cloud, service details can change, so you should always be comfortable referring to azure.com for the latest information. If you're going to be adopting Azure SQL Database, there's two key pieces that you want to keep track of. One is the SQL Database documentation, and the other one is the SQL Database pricing page. The prices, of course, are subject to change very often, and that page will come in very handy if you need to quote any sort of SQL database deployment. The links to both of these are in the resources for this lesson. In this lesson, we looked at the steps of creating a server. It is a logical entity. It does not match to a physical server. You have to pick a name and a region. Once you have that server deployed, you can create your database. There are several choices required here, such as the name, the service tier model, the compute model if you're using vCores, and then you have to decide the method of provisioning that you will use, whether it's the portal, the PowerShell, or the tsql commands. And reminder to always stay up to date and keep those links for the Azure documentation and the Azure SQL pricing page handy. Thank you for joining me for this lesson, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our demo, creating an Azure SQL database. In this demo, we're going to create a database with the Azure portal, then we're going to create a database with PowerShell commands, and then we'll do a lesson summary at the end. Okay, I'm connected to the Azure portal. We're going to go into create a resource. Then once you're in create resource, you'll see right here we find SQL database. As you can see, we have here the popular Azure services. So we find it right away and we just go ahead and click on create. If it wasn't showing up here, you can always search for it here in the search box anyway. So go ahead and go on create. And we're going to step through the different tabs of this creation experience. First thing, we want to select the subscription and we want to select the resource group. A resource group is a logical grouping of different Azure resources that you can put together to manage them as a whole. In this case, I'm going to create a new resource group. I'm just going to call it Warner SQL Demo. Say OK. And now we got to set the database details. Database, we can call it Warner SQL Demo. And for the server, I already have a pre-existing server here in my subscription. However, I'm going to create new. So in the Azure portal, you can take care of both creating the server and the database in the same create database experience. And now we have to select a server name. So I'm just going to go ahead and type in a server name. And we have to pick a location for the server. I'm just going to leave it here in East US. However, as you can see, we have lots of different regions for Azure around the world. And then we have to select here the authentication method that we want. As I mentioned before, Azure Active Directory is the preferred method. I'm going to select both the SQL and the Azure AD authentication method, just in case, for example, if you need to connect some sort of legacy application, then SQL authentication might still be useful. You also want to set an Azure AD admin for your SQL Server. In this case, I'm just going to select an admin account I have created for my demos here on my tenant. Go ahead and click on select. And then for the SQL authentication administration, I'm going to create a new server admin login and password. So I'm just going to go ahead and type in Warner admin, and I'm going to give it a strong password. And at this point, I'm going to click on OK. Now we have filled up the metadata for our server, but we still have to keep selecting some more options for the database. In this case, it says want to use SQL Elastic Pool. Elastic Pool is a way for SQL databases to share some resources. In this case, I'm not going to use it. By the way, we will cover Elastic Pool in a little bit more detail later on in the course. Then, the portal also asks you to select the workload environment for your database so that you get recommendations of configuration, whether you're using development or production. In this case, since it's demo purposes, it's similar to development. And you can see here how it switches into recommending a serverless database because it is not a production one. If I go back to production, you'll see now we went back to provision resources. I'm going to go back and select for that development database. And you'll see here we get some standard default selections. And you can go here and click on configure database and you can select different things. For example, you can see here the family of the hardware that's going to run your database, and you can select whether it's standard series Gen 5, and based on region and service tier selections, you might also get the other configurations to be available, like memory optimized, compute optimized, or the confidential computing. So in this case, I'm just going to leave it here with the standard Gen 5. Go ahead and click on OK. And because it is a serverless database, I can select the maximum amount of cores and the minimum amount of cores. In this case, the minimum is half a vCore actually, and the max is just 1. Now again, this is demo purposes, so this is perfectly fine for me. And you can see here we get an estimation on the side here of the cost of the database. Now keep in mind, it only gives us the cost of the vCore per second because we are using a serverless model, and you get an estimated storage cost depending on the storage that you have selected. As you can see here, there's an auto pause delay that you can configure, which is really what you want to do if you want to take advantage of the serverless model. And you can select whether to wait for some days of idleness, hours, or minutes of idleness. By default, it will say if it's been idle for 1 hour, then go ahead and pause the database. Next, you will select the max size for the database. In this case, it's set to 32 gigs as the default, and it allocates 9.6 gigs of log space. If you go higher, you'll see how the log space will be increasing proportionally with the amount of data that you want to provision. In this case, I'm going to go back and just go back to the 32 default. And here it says, would you like to make this database zone redundant? This means that Microsoft will have this database replicating across availability zones in the case that you're in a region that has availability zones. Now, if you make it database zone redundant, there might be a little bit more of commit latency because you have to have the replicas in sync. But if you are running a production environment, you definitely want this to be database zone redundant. In this case, again, this is all demo. So I'm just gonna say no and click on apply. As we go back to the main configuration page, you'll see we have to select here the backup storage redundancy, whether it's locally redundant, zone redundant, or geo redundant. In this case, I'm only gonna select locally redundant because I'm only gonna do this for demo purposes. Next is networking. Now, When selecting connectivity, you can leave it with no access as you create it and then enable it later on. You can do public endpoint or private endpoint. For ease of use and demo purposes, I'm just going to go ahead with a public endpoint. And then you can decide what firewall rules to set up right off the bat when you create your database. In this case, you want to allow Azure services. This is up to you. If you want to have the ease of connection of other Azure cloud services, you can say yes. And then it says add current client IP address. So the current client machine where I'm on, do I want to allow it to connect to this database as well? I'm going to say yes in this case too. Then we have the connection policy of the SQL database server, which means you can do a proxy, which all connections are proxy through gateways, or redirect, where the clients establish connection directly to the node that's hosting the database. By default, you can have it so that Azure will do a redirect if the client connection originates inside of Azure, or proxy if the client connections are originating outside of Azure. Now, I recommend you leave this as a default unless you have a specific requirement through the networking team in your company that specifies that you have to change away from that default. Encrypted connections, you're always going to be doing an encrypted connection to the Azure SQL database, and you have the different versions of TLS. I recommend you stay with the latest TLS 1.2 unless required to go back because of some sort of application legacy compatibility issue. Next, we're going to go into security. Right now, I'm not going to enable the Microsoft Defender for SQL. I'm not going to enable also the ledger tables. This is a feature of Azure SQL Database. If you needed your database to connect to another service through a managed Azure identity, you can set it up in this section. And finally, you can select here if you're going to use transparent data encryption with either a service managed key, so a key that is managed by Microsoft, or with a key that is managed by yourself. If you don't have a strong information security department that can really manage the key rotation, then I recommend you just let Microsoft manage the keys for you. We're going to look at some additional settings here. You can set the data source for your database to be either none, so it will be a blank database, a backup that you have already in Azure Storage, or a sample database that Microsoft provides. Then we have the database collation. This is very important to get it right. Remember that collation will determine how the SQL engine compares and sorts different character sets. And then finally, you can select the maintenance window for your Azure SQL database. During a maintenance, your Azure SQL database should be available, but you might experience some failovers. For example, if Microsoft is either refreshing hardware, or they are patching, or they are doing any sort of underlying change to the infrastructure. However, these disconnection attempts should be pretty short-lived. In this case, actually, for this particular region, you don't really have a choice. For this configuration, you have to stick to the system default, which is a maintenance window from 5 p.m. to 8 a.m. If you're going to create some tags, you can add them here. In this case, I'm not going to do that. Then just go into review and create, and you can see all the different configurations that you selected for your database, and just go ahead and click on create. Now the Azure portal will show the deployment is in progress, and after a couple of minutes, our database will be ready. Now we can see our deployment is complete. I can go to resource, and there it is, our Azure SQL database. We can go to overview, and we can see all the different configurations, and our database is ready to be connected to, which we'll do in the next section. Okay, I'm back in the Azure portal, and to create the database through PowerShell, we are going to be using a very handy feature of the portal, which is the Cloud Shell. Now the Cloud Shell is pre-configured for you, so it will authenticate you and give you a home on Azure Blob Storage, and you don't have to set up a local development environment. So I'm just going to go ahead here and wait for it to authenticate, and you'll see here I'm going to have a home for my PowerShell session, and then in the download package you'll find a PowerShell file called newdb. First thing we're going to do is verify that we are connected properly and that we can see all of our subscriptions. Now in my case, I have 3 subscriptions, and I want to select a specific one to create the server and the database under. And if you have multiple subscriptions, then you'll want to do this as well. In the next command here, so you can see we're going to get the subscription, and we're gonna pipe it to set the Azure context. So I'm just gonna head and do that. All right, now my Azure context has been set, and we can keep going here. Now to create a admin account for the SQL Server, I'm gonna have to use a PowerShell credential object. So I'm just gonna go ahead and create that right now here in my PowerShell session. And you can see here, I have to type in what I want for the credentials, and then the password for it as well. That credential object has been created now, and you'll see in the next command here, when I create the new AZ SQL Server, this is the name of the commandlet. I'm gonna pass in the resource group name, the location, the name of the server, and that admin credential that I just created. I'm gonna go ahead, paste that right in, and let's create the server. After a few minutes, the server is created and we can see all the different metadata associated with that server. Now we can go back into the script file and we're going to run the last command here, which is the new AZ SQL Database that will create the database here. And we're going to use the database name. We're going to specify the server that we just created. We're going to say that we want to use the general purpose edition of SQL Database, and we want 2 vCores in the Gen 5 compute generation, and we want it to be serverless. We'll go ahead and paste that in as well. Now we just get some warnings from Microsoft on some of the breaking changes coming up in the new AZ SQL Database. This doesn't really affect us for running this particular command, but it's just something that sometimes comes out in the output, as is the way that Microsoft uses to communicate to the users of their different commandlets. And after a few minutes, we can see our database has been created, and we can look at all the metadata as well that is attached to it, and you'll be ready to connect to it as well. In this lesson, through the demo, we were able to create a database with the Azure portal, which is a rich GUI-based experience, and really you just have to follow the form all the way through to the point of deployment. Then we created a database with PowerShell, and here we use the web cloud shell, so we have a built-in pre-configured environment. Then we just follow the straightforward step-by-step commands until the database was created. Thank you for joining me for this lesson, and I'll see you on the next one. Hello Cloud Gurus! Let's go over the section summary and recap the main points of every lesson. Lesson 1, what is Azure SQL Database? We talked about the definition of Azure SQL Database, how it is a Microsoft Azure Database as a Service product. Then we talked about the Database as a Service features, such as the management automation built in by the cloud provider, pay-as-you-go capabilities, and the elastic resources that you can scale up or down on demand. We also talked about different Azure SQL services that you might run into in your cloud journey, such as Azure SQL Managed Instance, as well as running SQL Server on Azure virtual machines. Then we moved on to Lesson 2, Service Cost and Value, where we went over the cost components of Azure SQL Database, which are compute, storage, and the service tier that you select for your database. Also learn about the different models of service tiers, which have the DTU or Database Transaction Unit based model, as well as the vCore based model, and we learned when it was a better fit for each one of those as well. In the vCore based model, we also learned about serverless or provisioned compute. Serverless will turn your database on or off as it is used. Provisioned compute will keep those resources provisioned, but serverless will have some warm-up time, and provisioned will have your resources always ready to go. And then we talked about the advantages of these type of cost component, service tier, and compute models, such as the cloud service advantages of flexibility, elasticity, and automation, and the decrease in operational responsibility for the DBA, where you can just focus on performance, security, change control, and testing the different features of the platform. In the next lesson, we talked about getting started with the service. First, we discussed creating a server, and a server is a logical entity in the Azure Data Center. It is not a physical server that is just sitting there in the Azure Data Center. You have to pick a name and a region for your server, and the server will group databases based on this for purposes of connectivity. Then you can create your database and place it inside a server. Several choices are required for your database, such as the service tier, the compute model, the size, etc. And then it has different methods of provisioning as well. You can create it through the portal, you can create it through PowerShell, or you can create it through T-SQL. And then we also discussed that if you are gonna get started using Azure SQL Database, you should try to stay up to date and always have the links handy for the product documentation and the product pricing page. Then we moved on to the demo of creating an Azure SQL Database. We went over the experience of creating a database with the Azure portal, and we went step by step on the rich GUI based experience and just followed the form all the way through to deployment. Then we also created that database with PowerShell, and then we used the Web Cloud Shell as a built-in environment that is already pre-configured and is right there for you in the Azure portal. And then we just followed the straightforward step-by-step commands to create our database through the PowerShell script. Join me on the next section as we look at connecting and managing your Azure SQL Database. Hello Cloud Gurus, and welcome to the next section in our Managing Azure SQL Database for SQL Server DBA's course. This is your introduction to connecting and managing Azure SQL Database. This section is broken down into the following lessons. We are going to be talking about networking, firewalls, and authentication to Azure SQL Database. Then we're going to do a demo of connecting to the database and manipulating the firewalls. Then we're going to talk about the security features built into Azure SQL Database. Then we'll talk about more differences between Azure SQL Database and SQL Server. And we'll do a demo of some of those management differences. And we'll wrap it up with a chapter summary. Some of the things that we will cover in this section include the type of connection endpoints that you can use to connect to Azure SQL Database, the database and server level firewalls, the security features that you will find in the service, differences from SQL Server, and more. Are you ready? Let's go! Hello Cloud Gurus, and welcome to our next lesson, Network, Firewalls, and Authentication. In this lesson, we are going to cover establishing a database connection and the steps to do so. We're going to look at the types of network endpoints offered by Azure SQL Database. We're going to look at the different service firewalls. We're going to look at the different authentication methods offered by the service, and we'll do a lesson summary. Establishing a database connection is a pretty straightforward process. First, we need to reach the network endpoint that provides the entry into the service. Then we have to go through the firewall based on the firewall rule setup. And finally, we have to be able to authenticate successfully to the service. Azure SQL Database uses the TCP protocol for connection. It uses port 1433, which by the way is a very common port used for SQL Server as well. The server name format is usually a prefix followed by .database.windows.net, and also a database name has to be part of the connection. The service has multiple types of endpoints. It has public endpoints, service endpoints, and private endpoints. And let's look at those in detail to understand the differences. A public endpoint, say we have a user and it's Azure SQL Database, just means that the SQL database has an internet-facing endpoint. It is protected by a firewall. Then the user has a client machine. The client machine has to have a valid route, get to that internet-facing endpoint, then get through the firewall and authenticate. The service endpoint works slightly different. Once again, we have the user and the Azure SQL Database. The user is going to get access through a service endpoint. What that means is that there will be a firewall, and then there will be a virtual network with the service endpoint. And so instead of putting individual IPs into the firewall, you put the whole range of that virtual network as allowed into that firewall. And you have to give permission for the virtual network to be able to establish that connection. In this scenario then, we need some sort of machine or jump box from that virtual network to get into the Azure SQL Database. So the user maybe would use a laptop, and then from the laptop connecting to the virtual network through that virtual machine, and then from the virtual machine that's inside the virtual network, jump and finally authenticate into Azure SQL Database. The last type of endpoint is the private endpoint. In this case, once again, we have Azure SQL DB, but now the access is through a private endpoint. And the difference here between the private endpoint and the service endpoint is pretty subtle, but it is still a different way to connect. So we'll have the virtual network as well, but the difference is that the virtual network doesn't have a service endpoint that is simply configured to allow the connection to the Azure SQL Database. Instead, Azure SQL Database publishes a private IP inside that virtual network. And then the rest follows the same. We would have some sort of jump box or VM, and then we would have the user use their laptop to jump into that machine, and then from that machine reach the private IP, and then that private IP would go directly into that private endpoint to allow the user to authenticate. In this particular scenario, the private endpoint gives the capability of completely disabling Azure SQL Database's public endpoint. Also keep in mind in this scenario, then the firewall does not come into play. You would have to use something like network security groups if you wanted to protect the access to the private IP that's inside the virtual network. Now there is another way to connect, but it is not exclusive to Azure SQL Database, but I still decided to add it just for completion here, and it is because Azure SQL Managed Instance supports virtual network placement. So in this case, what happens is that when you deploy an Azure SQL Managed Instance, you can actually deploy it inside a specific virtual network. And then the rest follows the same. You would have some sort of VM or jump box machine. The user will have their client go into that VM, and then from that VM straight into the Azure SQL Managed Instance, since, like I mentioned before, it is actually a resource that is directly deployed inside a virtual network that you provide. This is very important. Proper firewall and network security configuration is critical, especially for public endpoint databases. You want to make sure that you're not getting connection attempts from places that you do not want to authorize to be able to reach your database. The service also offers different types of firewalls. It has a server level firewall and a database level firewall. We'll look at that in detail as well. The firewall resolution works this way. We have a user trying to establish a connection, and then it's going to validate against that database firewall first. And then the database firewall is going to say, is this IP in range? And if it is, then the user has to authenticate. If the answer is no, then the server level firewall comes into play. Same thing happens. Is the IP in range? Yes, then you have to authenticate. No, then the user will get a connection denied with an error. The different firewall types, the database firewall and the server firewall, don't have the same use case, and you have to know when to use each one. Database firewall is for databases with different access requirements because it's at the individual database level. It is more specific then, because you can use the granularity of the specific database that you want to give access to. It is portable on failover, and we'll look at recovery in Azure SQL Database in a section coming up. But just keep in mind that if you fail over or fail back, the firewall rules travel with the database. There is more management, of course, because you have to manage those rules at the database level, and you most likely have multiple databases. But it is good for application or end user access to keep the access as tight as possible. The server firewall, on the other hand, is for databases with the same access requirements. It is less specific, of course, because the rules apply to all the databases in the server. It is not portable on failover, so you have to make sure that your primaries and secondaries are configured exactly the same way for the server firewall. There is less management, of course, because you only have to manage the server firewall and not the individual database firewalls. But the real intent for the server firewall is to protect for administrator or IT support access that needs general access to the server, and not really for individual application or user access. The service also supports different authentication methods, such as Azure Active Directory, SQL authentication, or a combination of both. Azure Active Directory provides the following functionality. It is role-based access control, so you create roles and you can grant those roles to some users or groups. You can create users, groups, services, or application objects and give them different permissions. It is high security with ease of use. It is very similar to the Windows Active Directory that a lot of administrators are used to. And at the same time, it provides a lot of security features such as time bounding or geographic bounding of authentication. On the other hand, SQL authentication provides role-based access control, but it's all based inside the SQL engine. You can create users, groups, or application objects. It does have lower security because it's all built inside SQL, and it doesn't have those advanced features that I just mentioned, like time bounding or geographic bounding. And it is more of a legacy method of authentication that is still around to support older applications that don't work with Azure Active Directory. Azure Active Directory then has the following advantages over SQL authentication. You can reuse the identities across servers because the users and the groups and all the other objects live at the Azure Active Directory level. You can have your password policies, such as password rotation, for example, all managed in one place. It is easier to manage at scale by using the different groups and applying those groups across multiple Azure SQL databases and multiple Azure SQL servers. It can be synchronized with Windows Active Directory, so if you already have some on-premises Active Directory, you can synchronize it to Azure Active Directory so the users remain the same, the groups remain the same, the passwords remain the same, and supports multi-factor authentication and other advanced policies like I just mentioned, like time bounding or geographic bounding. For all these reasons, Azure Active Directory is the preferred method of authentication, and you should try to use it every time you use Azure SQL Database. Something to keep in mind is that even if you do establish a successful connection, Azure SQL Database will close that connection if it remains idle for more than 30 minutes. In summary, in this lesson, we learn about the different types of network endpoints, such as the public endpoint, service endpoint, private endpoint, and then we learned about the different firewalls, such as the server firewall, the database firewall, and then we learned about the authentication methods in the service, like Azure Active Directory, SQL authentication, and why we prefer Azure Active Directory over SQL authentication. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our demo, Connecting to the Database. In this demo, we're going to look at configuring the service firewall for Azure SQL Database. We're going to look at configuring that database firewall as well. We're going to look at authenticating to the database through SQL Server Management Studio, and we'll do a lesson summary at the end. Okay, I'm connected to the Azure portal, and the first thing we're going to do is we're going to check out the server level firewall. So right now here, I'm on the main blade of my Warner SQL DB server. If I scroll down here, you'll find that under security, there's the networking section. Just go ahead and click on that. And if we scroll down here, you'll see that we don't have any firewall rules set up right now. So what happens if we try to connect? So let's go into Management Studio, and I'm gonna just go ahead and connect here. And I already pre-populated this, and we are going to be using Azure Active Directory for the authentication. Go ahead and click on Connect, and as expected, I am prompted here to authenticate into Azure Active Directory. Sign in, then I have to verify my identity. Again, this is some of the advanced functionality that is offered by Azure Active Directory. So I get a code on my phone, then I have to enter it, click verify, and I am connected to my Azure SQL Server. I can open this up on the databases, and we can see here the Warner SQL demo database. Also, if I open the system databases, you'll see here that we only have the master database. So obviously this is very different from SQL Server, where you would find the model or the MSDB databases as well in the system level. Now you might be wondering why we were able to connect if we didn't have any IP in the firewall rules. The reason for that, if I go back into the portal, you'll see where we have this exception that says allow Azure services and resources to access this server. And because this particular virtual machine is running inside Azure, it does not have any issues logging into the firewall, because this particular rule basically says if you have an Azure service or an Azure resource, then just let them authenticate and don't apply the firewall rules. Now, for convenience, and if it's not a production database, you might want to set this option, but to showcase here how it works with the real firewall working, I'm just going to turn it off as well. Go ahead and click on Save. Now, we're going to jump back into Management Studio, and we're going to disconnect and try again. Go ahead and connect. Try it again, and you'll see right away, now we get an error message here, and it says your client IP address does not have access. You can sign in to the Azure account to create a new firewall rule to enable the access. So this is a nice experience in Management Studio, where if you don't have your IP address in the firewall, it will let you do it right away straight from Management Studio. So we're going to do that right now. Click on Sign In, use the same account, and now Management Studio is going to create the rule for our IP address directly with Azure. Go ahead and click on OK, and now we hit a different error. This time it says that the account does not have permission to change the server firewall rule. Try again with a different account that is an owner or contributor of the Azure subscription or the server. So what's happening here is that our admin account is the Azure AD admin of the server at the database engine level. However, the firewall rules are set up at the service level. So we're going to give that demo admin account right now access to be the owner of that particular server at the Azure service level, and we'll try again. So let's go ahead and do that. So the way to do that, we go up here to access control, and now we look at the role assignments, and we're going to add a new role assignment. And we're going to do the role assignment. We click on the owner, then we go to members. You can see here, we can add members by selecting the members. We're going to do the demo admin, select, review and assign. And again, now we can see demo admin is added as an owner for Warner SQL DB server at the Azure service level. So let's jump back into Management Studio and let's try to create this rule one more time. Okay, and now we are in. So Management Studio created that rule now through the new owner role that we gave to that particular account. And if we go back into the portal as well and go back into the networking section, we can see that the rule is there now. And that's why we're able to connect. Now inside Management Studio, so I'm going to do a new query, and I'm going to paste here the script to create the database firewall rule. And remember, the database firewall rules have to be done through T-SQL. It does not have an interface in the Azure portal. So I'm going to go ahead and create a rule. And we'll see here, no problem creating the rule. And we can actually query some of the rules as well with some of the system views. Now, sys firewall rules only works at the server level, so we won't be able to see it here inside this particular user database, but we can see sys database firewall rules. In this case, we see that database level rule right here. Now let's see what happens then, now that we have a database level rule, if we remove the server level rule. So let's close this down. Let's go back into the Object Explorer and let's disconnect our client. Let's go back into the Azure portal and let's get rid of this server level firewall rule, and we'll save the change so that the firewall is updated. And now that we're back in Management Studio, let's go to connect, and we see again we get the experience saying, hey, you don't have a firewall rule that is allowing you into this server. Do you want to configure it? However, if we go to options, and here in the connect to database option, we say we want to connect to the Warner SQL demo database. In this case, it is not going to try to connect to master first, but instead it's going to go straight into attempting to connect to that database, and the database firewall rule will come into effect. As we can see, right away we get in there through the database firewall rule. We are able to create a new query, and we can just run something just to test it out. For example, select the version of the database, go ahead and execute that, and we can see we are connected successfully because of the precedence of the rules. We can hit the database firewall first and get into the database even if our IP is not on the server level firewall. Okay, I hope that demo was good at covering all these different topics. We looked at configuring the service firewall, which can be done through the portal, and then it applies to all the databases. We look at configuring the database firewall, which has to be done with T-SQL commands. It has no interface in the Azure portal. Then we looked at how it applies to a specific database, and we looked at authenticating to the database, used Azure Active Directory, so we didn't use SQL authentication, and we use SQL Server Management Studio and its built-in support for Azure SQL Database. That's it for this lesson. Thanks for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to the next lesson about security features. In this lesson, we are going to cover the cloud-only security features of Azure SQL Database, the security feature variations from SQL Server, some of the Azure SQL Server roles, and we will do a lesson summary at the end. Azure SQL Database has security features that are cloud-only or have variations compared to how they're implemented in SQL Server. Microsoft Defender for SQL, for example, is a cloud-only security feature that you can deploy and activate for your Azure SQL Database, and it has SQL vulnerability assessments as well as advanced threat protection. The vulnerability assessments is a proactive tool meant to find issues before they cause a security incident. It is a managed cloud service, so all you have to do is activate it. You don't have to install anything or manage anything. And it looks for misconfigurations in your Azure SQL databases or your users or your privileges. It looks for excessive permissions provided to different users and for unprotected sensitive data. The other feature is the advanced threat protection. This is more of a reactive tool, so it's meant to alert you when something is happening that is not good. It is again a managed cloud service, so you don't have to install anything, you don't have to manage anything. It generates real-time alerts, so you know what is happening to your database almost immediately, and it can alert on SQL injection attacks, anomalous query patterns, or suspicious database activity. And the service will learn over time more and more about your database and give you more important and relevant alerts. Another cloud-only security feature is the outbound firewall rules. This is Azure SQL Server, for example, has a firewall that is about the connections going out of the Azure SQL Server. For example, for connecting to Azure Storage or for connecting to other Azure SQL servers as well. Then there are features that have some variations. For example, we have always encrypted with secure enclaves, and this is a very exciting encryption technology. For example, you have an application, and then you have the database engine inside Azure SQL Database. The application has some data, then it sends it in clear text into the driver, then the driver will encrypt it to send it into the database engine, and then inside the database engine memory, it's still encrypted, and then there's a secure portion of memory that only gets computed through special hardware that can decrypt the information, do the computation, and then send it back. So inside this special portion of memory is called a secure enclave. It has a specific DLL that can decrypt that information, use that special hardware, and then send it back, encrypted back into the database engine, encrypted back through the wire, encrypted back into the driver. The driver will decrypt it and display the data back into the application. So this is for the most sensitive data you can find in your application. The cool thing about using always encrypted with secure enclaves in Azure SQL Database, when you use it in this service, it is available in any tier of Azure SQL Database. It uses a specific managed hardware, so you don't have to worry about buying or refreshing the specific hardware that supports the secure enclaves, and it is integrated with Azure Key Vault as well for the key management of this functionality. Another feature that has a variation is auditing. In Azure SQL Database, you can send your audit logs to a storage account, you can send it to an event hub for real-time event processing, or you can send it to a log analytics workspace if you want to then query those logs for important type of events. Transparent database encryption, which is a very popular encryption at rest technology for on-premises SQL Server, also has some variations in Azure SQL Database. In this case, it has built-in database encryption, so you always use it in Azure SQL Database, and it covers data and backups. It can use service-managed keys, so in this case, Microsoft has the keys used to encrypt that data at rest and the backups, or you can also manage the keys yourself through the Azure Key Vault service. Something to keep in mind is that managing your own encryption keys requires a mature information security practice. If you mismanage the encryption keys and you decided to do customer managed encryption keys, you could lose your data permanently. Azure SQL Database also offers specific server roles. This is the first one, MS Database Connector, and notice the way that these role names are constructed. It's hashtag MS underscore and then hashtag at the end as well. And this is to really differentiate them from other server roles that people might create in the server. MS Database Connector can connect to any database. Then we have MS Database Manager that can create and delete databases. We have MS Definition Reader, which can read all catalog views. We have MS Login Manager, which can create and delete logins. We have MS Security Definition Reader, which can read all the security catalog views. We have MS Server State Reader, so it can read all DMVs and functions across the server. And then we have MS Server State Manager, and this is a user role that can manage operations at the server level. These roles cannot be customized, they are static, and can only be granted to server level logins. In summary, in this lesson, we learned about cloud-only security features, such as the vulnerability assessments, the advanced threat protection, the outbound firewall, and then also about the feature variations that you may find in terms of security between Azure SQL Database and SQL Server, such as always encrypted with secure enclaves, which you don't have to worry about managing the hardware or refreshing it in Azure SQL Database. We learned about auditing and how you can send it not only to storage, but also to event hubs or log analytics workspaces. We also talked about transparent database encryption and how you can use Microsoft managed keys or your own managed keys. However, you better know what you're doing when you're managing your own encryption keys. Then we talked about the built-in Azure SQL Database server roles and how they are multiple static roles to match common requirements. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, Differences with SQL Server. In this lesson, we are going to go over product feature differences between Azure SQL Database and SQL Server. We're going to look at management differences. We're going to look at development differences. And we're going to do a lesson summary at the end. Let's talk about the product feature differences. First of all, SQL Server comes with a lot of stuff. So the SQL Server product is bundled with reporting services, integration services, analysis services, and more stuff like data quality services, master data management services, and many other things. Azure SQL Database, on the other hand, is 100% focused on providing a database engine. That's what you get when you deploy the service. For the other things that come built in with SQL Server, then you're looking at using related cloud services. For example, if you wanted to do reporting, you would use Power BI. If you wanted to do integration or data transformation, you would use Azure Data Factory. Or if you wanted to do some OLAP tabular models, you would use Azure Analysis Services. The idea here is to find a cloud equivalent to the functionality that you're looking for that was bundled with SQL Server. Let's look at the management differences. Restoring data is very different. you can't restore a SQL Server backup directly to Azure SQL Database. You can import a backpack file, use migration tools, or use SQL Server replication to replicate the SQL Server data into Azure SQL Database. Now, I do want to point out that Azure SQL Managed Instance does support SQL Server Backup Restore. So if this is a very important capability for you, you might want to look at using Azure SQL Managed Instance instead. Something to also keep in mind is that you are simply not the sysadmin of your server. So a lot of the tasks that you might have been doing in SQL Server as a sysadmin, you won't have to worry about them anymore in Azure SQL Database. For example, server configurations such as setting the max server memory, setting the max worker threads, sizing the data files individually, setting up tempdb, backing up and restoring things yourself with tsql commands, or applying patches. These are not your responsibility anymore. In terms of availability, there's also no log shipping, there's no mirroring, there's no failover clustering, there's no availability groups to manage. The service provides its own high availability and disaster recovery, and the configuration that you do have available is very easy to manipulate through the portal or through PowerShell. And we will look at that in a section coming up. System views like sysdm exec requests operate at the database scope, not at the server scope like SQL Server. So this is a management difference that you have to keep in mind when you're doing some troubleshooting as well. Tracing is also done with extended events only. There is no support for profiler server-side traces. Replicating data also works differently. Linked servers are replaced by the external table feature. So instead of just setting up a linked server that you can connect out to, you have to specify the specific external tables that you want to reach. SQL Server replication is limited. You can only be a subscriber for an Azure SQL database. There is a cloud-only feature, however, called SQL Data Sync that you can use. SQL Data Sync allows you to have an Azure SQL database that then can publish into a SQL Server database or into another Azure SQL database. This type of replication, however, is based on triggers, and you have to install agents on the SQL Server side if that's what you want to use. There is no error log file that you can open and read through, but there is a system log view instead that you can query, and we'll see that in a demo coming up. Now let's look at some development differences. There's no support for CLR, the common language runtime used by .NET. However, there's some CLR support on SQL Managed Instance. Features such as service broker messaging or database mail are not available in Azure SQL Database as well. However, they are supported in a limited way with SQL Managed Instance as well. If you're doing some performance training or troubleshooting, you don't track performance counters on Performance Monitor. You use system views or Azure metrics to track those resource levels in your Azure SQL Server or Azure SQL Database. Developing jobs is also different. There's no SQL agent service in Azure SQL Database. The job scheduling is handled by either Elastic Database Jobs or Azure Scheduler. The SQL Managed Instance again does offer SQL agent jobs, so if this is a really important functionality for you, you might want to look into SQL Managed Instance as well. In summary, in this lesson, we looked at the product feature differences, such as the Azure SQL Database being an engine only and not bundled with so many different products like SQL Server. Other cloud services replace those SQL Server bundle services. We have management differences, such as the sysadmin tasks being reduced. HA and the R are handled by the service, and you don't have to configure them in detail. There are development differences as well, such as no .NET CLR or messaging features, and jobs are handled by SQL Agent alternatives. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson. This is a demo on management differences. In this demo, we are going to look at retrieving the system log for Azure SQL Database. We're going to look at the differences in behavior of system views. We're going to look at how you set up a feature that requires a storage, since we don't have access to the local storage in the server. and we'll do a lesson summary in the end. Okay, I'm connected to Management Studio, and the first thing I want you to notice is over on the Object Explorer, there isn't a management folder like there is if you connect to an actual SQL Server. So under the management folder is where you would usually find the error log files. In this case, the closest thing we have is the sys.event.log view. I'm going to go ahead and execute that, close this out, and we can see here this view has a column for the different database names. We see master and my Warner SQL Demo user database, the start time and end time of the event. We get the event category, type, and event subtype. And we also have a description, which is rich text that you can use to read about what this event is. There are different types of events that get logged into this event log view, and it is the closest thing to the error log, as you get the different event categories, the timestamps, and as well as the description, similar to how you see the lines that you read in the error log file. Another view that is very useful is the sys.database connection stats view. I'm going to show it right now. You can see this is another view that shows the data from multiple databases. In this case, again, my two databases, master and Warner SQL Demo. It has the start time and end times, and you can see here these are aggregated in 5-minute intervals. And what this view shows is that over those 5 minutes, it will give you a success count of the connections, a total failure count, a connection failure count, terminated connection count, and throttled connection count. This throttled connection count is very interesting because if you are getting throttled connections, it means that Azure SQL Database is not letting you connect to the database because you're running out of resources. So this is a good signal to know that you have to scale up the resources in your database. And we'll see how to do that in a section coming up. Another view that I did mention on the slides as well is sys.dmexec requests, which in this case in Azure SQL DB works slightly different than in SQL Server. In SQL Server, this is scoped at the server level. Here in Azure SQL DB, it's scoped at the database level. So for example, right now I'm connected to master. I can execute this, and we'll see we get 3 user sessions. The one is suspended, one's running, one's suspended. They're running different select commands. Now if I go ahead and open Object Explorer, run a new query on that Warner SQL Demo, I'm just gonna go ahead, bring over this query over here and run it over there, and we'll see we get different results. Here we have session ID 61, 62, 85. Over here it's 56, 57, 68. So this is showing me the sysdmexec requests view for this specific database. And here we're showing us for this specific database as well. It does not show it for the server as a whole. Now the other thing I want to show you as well is what to do when you're dealing with features that require storage because you don't have access to local storage. You have to use cloud storage, and these scripts all are going to be part of the files associated with this lesson as well. So first thing you got to do is create a master key that is going to exist in your database. In this case, I'm going to set myself to my Warner SQL Demo database. I already did this step, and then after this you have to create a database scoped credential. It's basically going to store the shared access signature that the database needs to get permission into that storage account and container. So here in the example that I have in my subscription in Azure, the account is called East Demo Storage, and the containers you can see here is called Traces. Now I've regenerated a shared access signature through the Azure portal, and I pasted the secret right here. Now I'm gonna show you how to do that in the Azure portal. So over in the Azure portal, I'm in the storage account, and then I'm gonna browse over to containers. Then in containers, I'm gonna go into the container that I want to use to save my files. In this case, I called it Traces. Once you're in Traces, you'll see here on the left hand side where it says shared access tokens. Go ahead and click on that, and we have to create that shared access token to use there on our Azure SQL database. Now the most important thing here is to give it the right permissions. In this case, you have to not just give it read, but you have to give it add, create, write, and list. Then you have to select a valid time for that shared access signature to be valid. Usually select sometime into the future, and if you want, you can also allow some specific IP addresses for that shared access signature. Also allow protocols, HTTPS only or HTTPS and HTTP. Now I recommend that you do HTTPS only so that it is always secure. Then you click on this button that says generate SaaS token and URL, and then this right here that says blob SaaS token, you go ahead, you copy it, and this is what you used over in Management Studio as the secret. So you have to follow those steps in your Azure Storage account to be able to create this database scoped credential. Now to test this out, for example, you can create an event session. In this case, I created an event session called error session on the database. We're capturing an event called SQL Server.error reported, and we are adding some extra data to collect, like the client host name, the database name, the username, and we want to write into an event file. And you'll see here we set the file name on each demo storage using traces and the file errortrace.xel. So I'm gonna start that event session right now and we'll see what happens. So we see here trace has started successfully, and we're writing right now into the Azure Cloud Blob Storage. We can generate an error so that we have some data for sure. That tells me, oh, that's an invalid object name. There's no table called no table. And I can just go ahead and stop the session. And to validate that we did write into that file, we can go back into that Azure Storage account. Once we're here, we can go into the container and we can see, as expected, the error trace file was successfully written into the Azure Storage account. Okay, so let's look at our lesson summary. We did a retrieving of the system log done through a system view, not a file in storage. We looked at the differences in behavior of system views, how they're scoped at the database level, not the server level. And we looked at the differences in features that require storage, how we had to use Azure Cloud Storage instead of local server storage. And in order to enable that, the database needs to have permissions to the actual storage in the cloud. So that's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our section summary. In our lesson Network Firewalls and Authentication, we learn about the different types of network endpoints, such as public, service, or private endpoints. We looked at the different firewalls, such as the server firewall or the database firewall, and we looked at the different authentication methods, such as Azure Active Directory authentication or SQL authentication. Then, we did a demo of connecting to the database, where we looked at configuring the service firewall, which can be done through the portal and applies to all the databases. Then we looked at configuring the database firewall, which cannot be done through the portal and has to be done with T-SQL commands. Then we also looked at how it applies to a specific database. Finally, we looked at authenticating to the service by connecting using Azure Active Directory and SQL Server Management Studio and its support for Azure SQL Database. On the next lesson, we talked about security features, such as cloud-only security features like vulnerability assessments and advanced threat protection, outbound firewall, and we looked at feature variations such as always encrypted secure enclaves, which are done through managed hardware that you don't have to refresh or configure yourself. We looked at how auditing can be sent to different targets, not only storage but also event hubs or log analytics workspaces. We looked at transparent database encryption, which you can do with service or customer managed keys, and how it's very important to know what you're doing if you're going to do customer managed keys. And we look at the built-in SQL database server roles and how there are multiple static roles to match common requirements. On the next lesson, we looked at more differences with SQL Server, like the product feature differences, how Azure SQL Database is an engine only, very different to how SQL Server is bundled, and the other cloud services that are available replace SQL Server bundled services like reporting services, integration services, and so on. We looked at the management differences, how the sysadmin tasks are reduced, how HA and DR are handled by the service and you don't have to configure them yourself. We looked at development differences, such as the lack of .NET CLR or messaging features like Service Broker or Database Mail, and we talked about jobs and how they are handled by SQL agent alternatives. Then we did a demo of management differences, where we looked at retrieving the system log, which can be done through a system view. It is not a file in storage. We look at the difference in behavior of system views, which can be scoped at the database level. They are not scoped at the server level. Then we looked at the difference in features that require storage, such as Azure Cloud Storage instead of local server storage, and how you have to give the database permission to that particular storage to use the feature. Join me on the next section as we look at understanding the service tiers. Hello Cloud Gurus, and welcome to the next section in our Managing Azure SQL Database for SQL Server DBA's course. This is your introduction to understanding the service tiers. In this section, we're going to look at the service tiers fundamentals, including the details on the Database Transaction Unit DTU model. Then we're going to look specifically at the newer core-based tiers. Then we're going to look at a demo of scaling up the service tier, both with the Azure portal as well as the PowerShell. Then we're going to look at some of the Azure SQL Database optional modes like Elastic Pools. And we're going to do another demo creating a database Elastic Pool, again with the portal and the PowerShell. And we'll wrap it up with a section summary. In this section, we will look at concepts such as the DTU versus the vCore model. We will look at the differences between the different tiers in both of these models. We're going to look at Elastic Pools and how databases can share resources using these. We're going to look at Hyperscale, a very different architecture that is optimized for the cloud and not the same as the SQL Server on-premises, and more. Are you ready? Let's go. Hello Cloud Gurus, and welcome to our next lesson, Service Tiers Fundamentals. In this lesson, we're going to look at service tier characteristics. What defines a specific service tier? We're going to look at the different service tier models. This is something that we discussed earlier in the course, but we need to revisit now. We're going to look at the details of the DTU-based model. We're going to look at the DTU-based tiers. We're going to look at changing tiers as well. And we'll do a lesson summary at the end. Different service tiers define characteristics such as the database's size range, the performance that you can achieve with that database due to the resources that you can assign to it, the amount of concurrency, meaning how many parallel operations and users and sessions the database can service, the recovery characteristics of the database, so this is related to backups, high availability, disaster recovery, and some specific product features that are only available on some service tiers. Let's revisit the service tier models. We have the DTUs, or Database Transaction Unit based model, as well as the vCore based model. In this particular lesson, we are going to focus on the DTU model. The DTU based model stands for Database Transaction Units, and it is a blended measure of CPU, memory, and I/O resources. Higher DTUs equal more resources for your database. There are 3 DTU-based tiers. We have Basic, Standard, and Premium. DTUs are used to scale performance. Let's say, for example, you have a basic database, you have 5 DTUs, you're running 10 queries, and it takes you 60 seconds to do so. If you scale that database up to, let's say, a Standard 3, you would get 100 DTUs. That's a 20x improvement. So those same 10 queries should take you about 3 seconds to execute after you scale up that basic database to the Standard 3. Let's look at the characteristics of the basic tier. It has a size limit of 2 GB. It has a point-in-time restore range of 7 days. It has 5 DTUs of performance. On the Standard side, it has a size range of 250 GB to 1 TB, so there is a big jump in capabilities from basic to standard. It has a point-in-time restore range of 35 days. It has performance going from 10 all the way to 3000 DTUs. Here on the screen, there's the table with the amount of DTUs that you get on the different standard levels at the time that the course is being recorded. We go all the way from S0 with 10 DTUs to S4 with 200 to S12 with 3000. Finally, we have the premium tier in the DTU model. This one has a size range of 500 gigs to 4 terabytes. It has point-in-time restore range of 35 days, which is the same as standard. It has performance capabilities from 125 to 4000 DTUs. And if you look here on the screen, I have the table of the DTUs, the size range, and the in-memory gigabytes for the premium tiers. So we can see the DTUs go from 125 to 4000. The size in gigabytes can go from 500 to 1 terabyte all the way to 4 terabytes on P11 or P15, where we see there 4000 gigabytes. And the in-memory gigabytes go from 1 on P1 all the way to 32 in-memory gigabytes on P15. In-memory OLTP is a feature that is only available on the premium tier in the DTU model. Concurrency capabilities are also tied to the DTU tiers. These include the amount of external connections that the database can make. An external connection is when the database reaches out to another resource, the amount of workers that can process work in the database, and the amount of sessions that can be connected to the database. As we can see here, Basic has pretty low numbers in most of these, 3 connections, 30 workers, 300 sessions, whereas Standard goes from 6 to 150 external connections, all the way to almost 6,000 workers or even 30,000 sessions. And then Premium can do up to 150 external connections, 6,400 workers, and 30,000 sessions. You can move from a lower tier to a higher tier and vice versa at any point in time. This is one of the biggest advantages of being in the cloud and one of the core value propositions of using Azure SQL Database. When you change a tier, the duration of the change depends on the amount of data. Your charges will change once the new tier is in effect. Whether you're going up or down, you won't get charged more or less until the database has completely changed to the new tier. And you need to implement some retry logic in your application, as usually there's a small disconnection when the database switches from one tier to the other. In summary, in this lesson, we learn about the service tier's characteristics, such as size, performance, and more. We looked at the service tier models like the DTUs, the vCore. We looked at the DTU tiers, such as Basic, Standard, and Premium. And we talked about changing tiers and how that can be done at any time. That's it for this lesson. I'll see you on the next one. Hello, Cloud Gurus, and welcome to our next lesson, Core-Based Tiers. In this lesson, we're going to look in detail at the vCore-based model. We're going to look at the vCore model tiers. We're going to learn about hyperscale, which I wanted to single out because it has a very different architecture compared to the SQL Server product that we know. And we will do a lesson summary at the end. The vCore-based model allows you to select the exact amount of vCores, memory, and provision storage. It is easier to migrate from on-premises since you don't have to do any conversion into some other unit of performance like it happens with the DTU model. It offers cost benefits if you already own SQL Server as well, as Microsoft will allow you to port some licenses into the vCore-based model. The vCore-based model also has 2 different compute resourcing models. We can do serverless compute, where the database is charged by the second and it only activates when you need it. Or we can do provisioned compute, which is more responsive as the resources are always available to you, but you're always paying for your provisioned resources. The vCore model has the following service tiers: General Purpose, Business Critical, and Hyperscale. General Purpose has a size range up to 4 terabytes, has point-in-time restore range of up to 35 days, can have up to 128 cores, has up to 625 gigabytes of memory, and uses a remote SSD storage type. The Business Critical tier has a size range of up to 4 terabytes as well, has point-in-time restore range as well of up to 35 days, has up to 128 cores as well, memory up to 625 gigabytes as well. However, it has local SSD storage, so it is a lot more responsive than the general purpose tier, and supports in-memory OLTP as well. The hyperscale tier has a size range of up to 100 terabytes. This is a big leap from the other tiers. It has point-in-time restore capabilities again of up to 35 days, can go up to 128 cores, up to 625 gigabytes of memory. However, it has a very different storage architecture. It is a multi-tiered architecture that we will look in detail in this lesson, and overall has a different architecture compared to SQL Server. Concurrency is also affected in the vCore tiers, just like it is on the DTU model. It also has limits on external connections, on workers, and on sessions. A big difference here between the vCore model and the DTU-based model is that both general purpose and business critical have the same limits on external connections, workers, and sessions. And hyperscale is also very similar. The only difference is that hyperscale has a slightly lower worker limit, from 12,800 in the other two to 8,000 in hyperscale, which is a pretty big number anyway. The different tiers also have different recovery characteristics that I'm not covering in this lesson, but we will discuss in an upcoming lesson in detail. Now I want to drill down here into the hyperscale architecture, as it is very different than the SQL Server on-premises or virtualized that we know. Hyperscale is composed of different compute nodes. These can be primary replicas as well as high availability replicas, and they have local SSD storage for caching. There's also a third type of replica that you can use in hyperscale called the named replica. This type of replica is not used for high availability, but is used for scaling out read-only workloads. The primary replica sends log records into a log service, and this log service redistributes those log records to the different replicas. On top of that, the log service also sends the log records to be applied to a page server. This page server keeps track of all the different database pages, also has an SSD cache, and can serve the database pages back into the replicas if they need them because they have moved out of memory. Finally, the page server is also connected to cloud storage. Here is the permanent storage place for the data files, as well as snapshots of those data files, which enable the recovery characteristics of the hyperscale architecture. So we can have one application, for example, that has a read-write workload going to the primary replica. It has a read-only workload that they can send to the HA replica. And then we can have another application that has another read-only workload going straight into the named replica. And you can continue this model so on by adding more named replicas and more applications as long as they are doing read-only workloads. This different architecture gives hyperscale different features than the other two vCore tiers. Hyperscale databases can go up to 100 terabytes of size. They do faster database backups and restores because it is based on snapshots of the cloud storage. It has higher log throughput thanks to the log service as well as the SSD storage. It can do really rapid scale out by adding more named replicas, as well as rapid scale up by adding resources either to one of the replicas or to the main primary replica that is doing the read-write workload. In summary, in this lesson, we looked at the vCore-based model and how it has specific core, memory, and storage configurations that you can select. It can be used in a serverless or provisioned resources mode. It has different tiers as well: general purpose, business critical, and hyperscale. Then we did a drill down into hyperscale. We learned about the very different database architecture divided in compute nodes, log service, page server, and cloud storage, and how hyperscale is optimized for large database sizes going up to 100 terabytes and still providing fast backup and restore due to the snapshot capabilities. Thank you for joining me on this lesson, and I'll see you on the next one. Hello Cloud Gurus and welcome to our next lesson. This is a demo of scaling up the service tier. In this lesson, we are going to look at importing a backpack file into a database in Azure SQL Database. Then we're going to scale up that database with the Azure portal. Then we're going to scale it up with the PowerShell. And we're going to compare performance from when we started to where we ended with SQL Query Stress. Finally, we will do a lesson summary. Let's check it out. Okay, I'm connected to the Azure portal, and right now I am in the page for the SQL Server that we've been using here in the course called Warner SQL DB Server. So first thing I'm going to do is show you an easy way to create a database if you have a backpack extract from SQL Server or from another Azure SQL database. Right here in the server page, you go to Import Database. Then you have to select the subscription where the database is going to be resourced from. And then we have to select the backup file. You go here and click on Select Backup. I have multiple accounts here in my portal, and I stored the backpack file inside this particular account, inside this particular folder. I'm going to provide this backpack file as well as part of the package that goes along with this lesson. So if you want to follow along, you will have exactly the same database that I do. Once here, I just need to select this file, and then we have to select the pricing tier for the database. So I'm going to go into configure the database, and for this particular demo, I am not going to use the serverless model. I'm going to use the provisioned compute model, and I'm going to stay here in the general purpose tier. I'm going to scroll down here, and I'm going to stay here at the minimum of 2 vCores in the general purpose model, and we're going to leave that data max size of 32 gigs the same, just as it is. Go ahead and click on Apply. Then we have to set the database name, which gets imported from the backpack, just T1 in this case. I'm going to leave the default collation, and then you have to select the authentication type so that the Azure portal can import the database into the actual server. So we have both SQL Server authentication or the Active Directory authentication. So I'm going to fill up here the credentials for the Active Directory admin and password for this server. And once it's filled up, just go ahead and click on OK. And we see here we have import operation has been accepted, and we can look at the history as well to keep track of these operations. The way this happens, you can go here to the SQL Server page and scroll down, and you see this option that says Import Export History. Let's go ahead and click on that and refresh this. And after a couple of minutes, as you can see, you will get the status of your database import process and a progress percentage tracker. Once the import operation has completed, we can go back here to the list of databases on the server, and you can see we have our T1 database, and we have the pricing tier here as well. It says general purpose standard series Gen 5 with 2 vCores. We can go into Management Studio and connect into this database as well. And we can run a query against this view database service objectives, and we see we get that same information here from the system view. Edition general purpose, and we are using general purpose Gen 5 _2 for the 2 vCores, as well as no elastic pool and the name of the database being T1. Now at this point, I'm going to switch into SQL Query Stress. SQL Query Stress is a very handy tool for testing the performance of queries against SQL Server or Azure SQL Database. I've already configured the connection for my Azure SQL T1 database, and I'm just going to run a very simple query, select star from a table called Azure Partition Test Order by a record date field. I'm going to use 50 iterations and 50 threads for a total of 2,500 iterations. And we're going to see how long that takes. Go ahead and press go. And it took approximately a little bit less than 10 seconds with the current resources that we have for that T1 database. Now I'm going to switch back into the Azure portal. And if I wanted to change that database and scale it up from the portal, it's very simple. I just go into the database, into the settings of compute plus storage, and here I can switch the tier if I wanted to switch the tier. Or if I just want to scale up the amount of cores given to that general purpose database, I can do it through this slider as well, all the way up to 128 if I wanted to. We're going to leave it back here on the 2. And instead of applying this change here through the portal, let's apply it through the PowerShell. So once again, I'm going to activate the Cloud Shell. And now as part of the download package, I have a file called scaleupdatabase.txt. First, we're going to set the active subscription as part of the context, similar to how we did it in the previous demo. And now that I have the right subscription as the context of the Cloud Shell session, the command to actually scale up is very simple. It's set AZ SQL Database commandlet, and we pass in the resource group name, the database name, the server name, the edition that we want to target, in this case general purpose, and the requested service objective name. In this case, we want to move from 2 cores to 4 cores. So I'm going to pass in GP_Gen5_4. And to get the values of these requested service objective names, you have to go into the Azure documentation. I am going to be adding a link as well for this lesson to the page that shows these codes for every single different resource tier. But for now, let's go ahead and run our scale operation. Go back into the shell, paste that in, and we just have to wait a couple of minutes for the change to take effect. And the change has completed, and we can see here, if we go back into Management Studio and rerun our query, we can notice here that the service objective has changed from GP_Gen5_2 to GP_Gen5_4. As well, if we go into SQL Query Stress, we can run that test workload again, and we can see a very noticeable difference almost immediately, where the runtime of the test has changed from 9 seconds to only 4 seconds. In this lesson, we imported the backpack file into a database, which is an easy way to apply both schema and data into a new Azure SQL database. We scaled up with the Azure portal. It's very easy to follow graphical user interface to adjust the resources or switch the tiers. We also scaled up with PowerShell, and this can be done simply by using the set AZ SQL Database commandlet. And finally, we compared performance with SQL Query Stress, verifying the impact of the scale up operation by being able to do the same operations in a smaller amount of time. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, Azure SQL Database Optional Modes. In this lesson, we are going to look in detail at the serverless compute model and just discussed a few configurations that we haven't covered yet in this optional mode of running your database. Then we are going to talk about a new concept, the elastic pools, which is a way for your single Azure SQL databases to share resources. Then we're going to look at other elastic capabilities that are part of the Azure SQL Database family, and we will do a lesson summary at the end. As a refresher, the vCore-based model offers a couple of different compute resourcing models, the serverless compute and the provision compute. The serverless compute should be used when you are okay with warm-up time, so the resources are not always immediately available for you. It is used to fit unpredictable needs when you don't know exactly how much compute you will need for your application or users. It has intermittent usage patterns, so it can go on and off depending on usage as well. And it has a few features, such as automatic compute scaling that is not in the provisioned resource model, and it is billed by the second, unlike the provisioned resource model, which is billed by the hour. Serverless databases receive a few parameters when you create them: the minimum amount of vCores, the maximum amount of vCores, as well as an auto pause delay. This is the time that the database will wait while being idle before going into the pause mode. The auto pause delay has a minimum delay of 1 hour. That is, your database has to be idle for 1 hour before the service will shut it down. It also has a maximum delay of 7 days. That will be your database being idle for 7 days straight before the service will shut it down. You can tweak from the minimum all the way to the maximum in increments of 10 minutes. And the autopause can actually be disabled. So once your database ramps up, the only way to shut it down would be to do so manually by the administrator. There's an interesting detail here about how serverless works the first time that a connection is done when the database is paused. A connection is attempted, and then you will receive an expected error 40613 that says database is unavailable. However, behind the scenes, the service will start ramping up the resources for this database. The database will resume after a small period of time, and you have to retry your connection to be able to establish the connection once that database has ramped up. The latency to auto-resume is around 1 minute, and the latency to auto-pause is between 1 or 10 minutes after the expiration of the delay period. There's another model to discuss now, which is called the elastic resource pool. This allows you to have single databases that share resources. For example, if you have the activity for one database that has been provisioned some compute, then you will have some times of the day where it's not used, and this can accumulate to quite a bit of time where the resources are simply idle. If you were to group a bunch of databases that have non-overlapping work patterns, you would be able to shrink the time and the amount of resources that are idle and maximize the use of the resources that you are provisioning. In this case, for example, we can see in the chart for many databases, the pink areas have shrunk because more databases are using more resources. Elastic pools can be resourced by using EDTUs, Elastic Database Transaction Units, and these are the same as the DTUs. The only difference is that they can be shared amongst different databases, and you can also create an elastic pool with the vCore based model and select the exact configuration of resources that you want in your elastic pool. Elastic pools are well suited for a large number of databases with low average utilization and relatively infrequent utilization spikes. Your savings will be increased the more databases you can add to the pool. Elastic Pool Billing has no per database charge for the elastic pool. You're billed for each hour the pool exists at the highest EDTU or vCores, regardless of usage or whether the pool was active for less than an hour. So the more databases you can put in the pool and the busier you can keep the pool, the more cost efficient it will be. EDTU based pools can be basic, standard, and premium, similar to the DTU based tiers. vCore based pools can be general purpose or business critical. At this moment, there is no hyperscale based pool. Pools have different properties, like the resource model that you're going to use, whether it's DTUs or vCores. Then you have to select the tier within that model. For example, standard in the DTU model or general purpose in the vCore model. Then you have to select the resources that you're going to assign to that pool, whether it's EDTUs or vCores plus storage in the vCore model. A pooled database also has a few extra properties. You can have the max storage per database in the pool. You can have a minimum amount of DTUs or cores per database, so the pool always reserves these resources for each database. And you can also have a maximum amount of DTUs or cores per database, so that a single database cannot starve all the other databases from resources. Azure SQL Database also offers some other elastic capabilities that fall outside of the scope of this course. There's the Elastic Database.NET library. There's Elastic Database jobs as well that you can run in the service and can execute against multiple databases. And there's even an Elastic Query capability that allows you to run a query against multiple databases at the same time. And I'll leave some links in the references for this lesson so that you can look at these other capabilities in detail. The nice thing about all this is that you can integrate them all together to create really flexible cloud applications. You can build an application that scales out over multiple databases using that Elastic.NET library. You can use the Elastic jobs to manage groups of databases with ease and cost efficiency. And you can query a table in multiple databases through one connection using that Elastic query as well. And this is all enabled by using Azure SQL Database. In summary, in this lesson, we looked at the serverless compute model, how it has some serverless parameters that you can select, such as the auto pause delay, for example. We looked at the first connection process and how it is expected to fail the very first time, so you have to have retry logic. And we discussed the expected latency in serverless operations when it ramps up and when it ramps down. We also talked about the Elastic Pool model, the use case for Elastic Pools to share resources amongst databases that have infrequent spikes and non-overlapping workloads. We looked at the pool properties depending on the DTU model or the vCore model. We also looked at the pool database properties, such as the minimum amount of resources, the maximum amount of resources, and the max storage per database. And we looked at some other Elastic capabilities that Azure SQL Database enables, such as the .NET library, Elastic Jobs, Elastic Queries, and how these capabilities can all be integrated to create the really flexible cloud applications. Thank you for joining me on this lesson, and let's go over to the next one. Hello Cloud Gurus, and welcome to our next lesson. We are going to do a demo of creating a database Elastic Pool. In this lesson, we are going to look at an easy way to make a copy of a database. So we have a couple of databases to play with. Then we're going to look at creating an Elastic Pool with the Azure portal. Then we're going to look at creating an Elastic Pool with PowerShell. And we will look at how you verify the resources are being shared by using the same tool we used in the previous demo, SQL Query Stress, and we will do a lesson summary at the end. Let's check it out. Okay, I'm back in the Azure portal on the page for that T1 SQL database that we created in the previous demo. And the first thing we're going to do, and this is another trick that you can use in the Azure portal, is an easy way to make a copy of a database. Just go ahead to the database page and click on copy right there. And we're going to create a copy of this database so that we can do a test with an Elastic Pool. So there's a bunch of fields already pre-populated because this is a copy. And I'm just going to change the name here to T2. And I'm going to change the target server to be the target server that we've been using so that both of them are going to be on the same server. Now there is a question here whether you want to use SQL Elastic Pool so that you could create the pool and copy the database at the same time. But to make it more clear how the process works, let's just do the copy first and then we will go ahead and create the pool. I'm going to configure the database and I'm not going to put it into 4 cores. Let's just bring it back down to the minimum of the 2 cores and go ahead on review and create. And let's create that copy database. Okay, once the deployment is complete, we can go to the resource and we have our brand new T2 database ready to be used. However, we are not going to use it right away. Let's now put it inside a SQL pool with the T1 database. So the best way to do that is to go back into the server and you'll see at the very top we have this new Elastic Pool option. So I'm going to head and click on that. And we have to give the pool a name. In this case, I'm just going to call it test pool. It's going to be in that same server. And now we have to configure our pool. So what tier do we want in our pool? In this case, we're going to use the general purpose tier. And what is going to be the hardware for the pool that we want? So we're going to stay on Gen 5. And now we have to pick the amount of cores in our pool. So let's say, for example, we're going to slide up to 4 vCores on the pool, and we're going to leave it here as 32 gigs in the pool as well. There's some options here for zone redundancy. If this was production, I would recommend that your pool should be zone redundant, but in this case, for demo purposes, I'm just going to say no and click on apply. And at this point, we can review and create the pool. Go ahead and click on create. Once the deployment is complete, we can go to the resource and we get to the page for that test pool. Another way to get to the pool page is to just go back into the actual server, and then on the side there's also the option of SQL Elastic Pools, and I can see the test pool there as well. You can click on it and then we're back to that same page where we were before. Now I can go here to the databases that are part of the pool, and we can click on that option right here, Add Databases. And it will give you the different databases that are part of that server, and you can add to that pool. So go ahead, for example, we can click T1, T2, and apply, and it would add them to the pool as well. Now I'm not going to do this, and instead we are going to go into the Cloud Shell again and create another pool with the PowerShell and add those databases to that pool instead. So I'm going to go ahead and open the Cloud Shell, make it big again. And in the download package for this lesson as well, there is a file called Working with Pools. First thing we're going to do is to set the active subscription, just how we've been doing it on the previous demos. And the next step now is to create the Elastic Pool. You see, we use the new AZ SQL Elastic Pool commandlet. We pass in the resource group name, the server name, the Elastic Pool name, the addition of the pool, the amount of vCores in the pool, the hardware generation, in this case Gen 5, and the database vCore minimum and the database vCore maximum. In this case, we're going to say, hey, we want the pool to be from half a core to 2 cores total, for example. Going to go ahead and click on that, copy paste it over, and let's create that pool. Now the pool has been created, and now we can add the different databases to it. We have to use the set AZ SQL Database commandlet, pass in the resource group name, server name, database name that we want to put in the pool, and the Elastic Pool name. So go ahead and we're going to run this in the Cloud Shell as well. And it might take a couple of minutes here for the database to be added to the pool as well. Once this is done, we go back and we're going to add the other database, T2, into the pool as well. After this command completes, then we will have another pool called test pool PS, and both T1 and T2 will be part of that pool. Now I can go back into Management Studio and run the same query we used in the previous demo. And if I execute it now, we will see where the addition says general purpose, the service objective says Elastic Pool, and now we have the Elastic Pool name, test pool PS, that this database belongs to. Now we can also go into SQL Query Stress, and I have 2 different windows of SQL Query Stress open. One is connected to T1 and the other one is connected to T2. So if I go ahead and run the test, we can see here the same 2500 iterations we did before. As expected, if it's just for one database, it takes close to 9 seconds. If I go ahead and run it for T2 as well, it will take a similar runtime, close to 9 seconds too. Now, to verify that they are indeed sharing resources, let's see what happens when we run both of these at once. And as we can notice now on the screen, the test is going to take slightly longer for both of them because they are no longer being able to use all the resources, but instead they are sharing them through that Elastic Pool. In this lesson, we made a copy of the database, which is easily done with the Azure portal. Then we looked at creating an Elastic Pool with the Azure portal. Once again, you can adjust the resources of the pool through the graphical interface. You can select the databases to put in the pool and put the pool in activity. Then we looked at creating an Elastic Pool with PowerShell, which is easily done using a new-AZ SQL Elastic Pool commandlet. And finally, we verified that the databases were sharing the resources by using SQL Query Stress. And we verified the impact of the shared resources by observing how the databases slow down when both of them are running at the same time. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our section summary. In Service Tiers Fundamentals, we looked at the different service tier characteristics such as sizes, performance, and more. We also looked at the different service tier models, the DTU or Database Transaction Unit, or the vCore-based model that allows you to select exactly the amount of cores and storage that you want for your database. We looked then at the DTU model in more detail, including the basic, standard, and premium tiers and the resources that you get with those, as well as looking at the process of changing tiers and how this can be done at any time, whether to scale up or down. In core-based tiers, we drilled into the vCore-based model, and we looked at how you can select specific core memory and storage configurations. It can run in serverless or provision resources mode. There's also vCore-based tiers, just how there is in the DTU-based model. These are general purpose, business critical, or hyperscale. And we looked at the hyperscale service tier, which has an architecture that is very different from the on-premises SQL Server, and it is optimized for large database sizes. Next, we did a demo of scaling up the service tiers. First, we imported a backpack file into a database using the Azure portal, a very easy way to import data into your Azure SQL Server. Then we applied both schema and data through that backpack file. Then we scaled up with the Azure portal, which is a very easy to follow graphical user interface to adjust resources or switch tiers. Then we scaled up with PowerShell, and again, very easy process using the set-az SQL Database commandlet. We compared performance with SQL Query Stress, and we were able to verify the impact of the scale-up operation by looking at how our workload had its time reduced in half. In the next section, Azure SQL Database optional modes, we looked at the serverless compute model in more detail, including the serverless parameters that we can use, such as the min vCore, max vCore, or the auto delay pause. We looked at that process of establishing the first connection and how it's expected for it to throw an error on the first time, and so you have to have retry logic. And we also looked at the expected latency for the serverless process to shut down or ramp up a database after periods of inactivity or after the first connection is attempted. Then we looked at elastic pools. This is a very cool feature that allows different databases to share resources if they don't overlap in their workloads. We looked at the pool properties, which include selecting a model and tier, just how you would do it with a single database as well. Then we looked at the pool database properties, which include the storage, the min-max DTUs, or the min-max vCores. Then we looked at other Elastic capabilities offered in Azure SQL Database, such as the .NET Library, Elastic Jobs, and Elastic Query, and how you can integrate all these different capabilities to produce very flexible applications. Next, we did a demo of creating a database elastic pool. We started by making a copy of the database through a very easy to use option in the Azure portal, and then we created an elastic pool with the Azure portal. We looked at how you can adjust the resources of the pool and how you can select databases to put in the pool. Then we looked at creating an elastic pool with PowerShell. Very easy process again using the new-az SQL elastic pool commandlet. And we verified the resource sharing with SQL Query Stress, and we were able to observe how the databases would run slower when both workloads were happening at once. Join me on the next section as we look at recovery in Azure SQL Database. Hello Cloud Gurus, welcome to the next section in our Managing Azure SQL Database for SQL Server DBA's course. This is your introduction to recovery in Azure SQL Database. In this section, we will go over the following lessons. First, we will look at the backup capabilities of Azure SQL Database. Then, we will look at how you perform restores in the service. Then, we will look at a demo of restoring a database in the Azure portal. Then, we are going to be talking about high availability and disaster recovery. And we'll do a demo of configuring an auto failover group for your Azure SQL Database. And finally, we will do a section summary. Examples of some of the topics that we will cover include backup configurations that you can use in the service, long-term retention of backups if you need more than what is included out of the box, high availability architectures in the service, disaster recovery options, and more. Are you ready? Let's go! Hello Cloud Gurus and welcome to our next lesson, Backup Capabilities. In this lesson, we are going to go over backup fundamentals as related to the service. We are going to look at short-term retention. We are going to look at long-term retention. We are going to do a lesson summary at the end. First, automatic backups. This is something that is built into the service. It will always happen as part of it, and it has a 10-minute recovery point objective for in-region backups. This means for the backups that happen in the region and are kept in that same region. The backup schedule that is built into the service will take a full backup once a week, a differential backup every 12 to 24 hours, and a transaction log backup every 10 minutes. The hyperscale tier is a little bit different because it uses a mix of storage snapshots and log backups to provide a 10-minute recovery point objective. So it does have the exact same RPO, however, it uses a slight different mix of the backup types. In terms of short-term retention, we have the DTU tier with 7 days maximum of short-term retention for basic and 35 days for both standard and premium. In the vCore tier, it's very interesting. There's actually no change in the maximum short-term retention that you can set up for your databases. It doesn't matter if you're doing general purpose, business critical, or hyperscale, the maximum is 35 days. Here's the breakdown of the backup cost. The DTU-based model actually includes the backup cost as part of the total price. In the vCore model, it's slightly different. It has no additional charge for backup storage up to 100% of your total provisioned database storage. Once you go over that 100%, you will start to pay per gigabytes consumed per month. Backups also have different options in terms of redundancy. That means how many copies of the backups are kept. You have locally redundant storage that can be used to keep the backup copies. You have zone redundant storage, and you have geo-redundant storage. Let's look at each one of these in detail. Backups in locally redundant storage are kept in one primary region in one availability zone. And you can see here, for example, I have backup copy 1, 2, and 3, both in that same AZ in that same region. Backups in zone redundant storage are copied across different availability zones still in the same region. And there's synchronous copies that happen. So there's always 3 copies of the backup file across 3 different AZs. Backups in geo-redundant storage get copied asynchronously from one availability zone in a primary region to another availability zone in a secondary region. In this case, you end up with 6 copies of the backups. This is the highest redundancy option that you can get in Azure SQL Database. A word of warning here. If you delete a database, you can still restore it as long as you're still inside the retention period if you're only using short-term retention. However, if you delete the server, all short-term backups are deleted and you will not have the restore capability. If you need backup retention that goes beyond the 35 days offered as the maximum, then you're looking at long-term retention. And Azure SQL Database offers this up to 10 years in Azure Blob Storage. Long-term retention uses the full database backups. It is configured through the Azure portal, the command line interface, or PowerShell. It requires creating a retention policy to describe the combination of backups that you want to keep in long-term retention. The long-term retention policy is composed of a weekly retention with a parameter named as W, a monthly retention, that is the M parameter, a yearly retention, that's the Y parameter, and if you are using yearly, you have to specify the week of the year that you want to keep, and that uses a parameter called week of year, and you use these parameters to configure these long-term retention policies. Let's look at an example. I have W set to 0, M set to 0, year set to 5, and week of year set to 3. So that means that the third full backup of each year will be kept for 5 years. There will be no monthly backups kept, nor will there be any weekly backups kept either. Let's look at another example. We can have W equals 6, M equals 12, Y equals 10, and week of year equals 20. This means that each weekly full backup will be kept for 6 weeks, except the first full backup of each month, which will be kept for 12 months, and the full backup taken on the 20th week of the year will be kept for 10 years. So as you can see, using these 4 parameters, you can make all kinds of different backup policies to fit your long-term retention requirements. Long-term retention cost is charged in gigabytes per month for both DTU and vCore-based models. In summary, in this lesson, we learn about the backup fundamentals, including how it's always automatically triggered by the service, the schedule that the service uses by default. We looked at the short-term retention, maximum retention periods. We looked at the backup cost. Then we looked at backup redundancy, locally redundant storage, which is always same region, same availability zone. We looked at zone redundant storage, which is same region, different availability zones. And we looked at geo-redundant storage, which is across different Azure regions. Then we looked at long-term retention, which is configurable for up to 10 years, uses Azure Blob Storage, and is configured through retention policies that can be incredibly flexible using the parameters of week, month, year, and week of year. That's it for this lesson. I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, Performing Restores. In this lesson, we are going to look at restore targets that you can use for restoring your Azure SQL Database backups. We're going to look at the local restore options that you have. We're going to also look at the different geo restore options that you have when you need to do a geo restore of your Azure SQL Database backups. We are going to look at the different restore methods you can use, and we will do a lesson summary at the end. When you need to restore a backup, the restore can be done to the logical server that's hosting the database or to another region. When you're doing a local restore, you can restore to a new database, to the same logical server to a specific point in time, or you can restore a deleted database on the same logical server up to the point of the deletion time. And finally, you cannot overwrite an existing database. If you want to replace a database with a restored copy, then the trick here is to rename the original database, perform the restore, and then rename the restored database to the original name, and at that point, you can drop the old database. If you're doing geo restores, then the option is to restore a backup to a new database on any server, on any region, up to the latest geo-replicated backup. All backup types are geo-replicated to support point-in-time recovery. Something to keep in mind is that restoring a database is a size of data operation for all tiers except hyperscale. That means the larger your database is, the longer it's gonna take. But once again, hyperscale here is the exception. Geo restores in particular have a 1-hour RPO, recovery point objective. That means you can experience up to a 1 hour of data loss through a geo restore, and the reason here is due to the possible delay in geo replication. Something to keep in mind, you have to have a good strategy that is a mix of local backups, geo restores, and possibly high availability and disaster recovery, which we will cover in a future lesson. Restores can be done through the Azure portal, Azure PowerShell, the Azure CLI, or the Azure REST API. So there's a lot of different options depending on what you're trying to do and what you feel comfortable with. In summary, in this lesson, we looked at the different restore options, such as the local restore or doing a geo restore. We looked at the time span of a restore, which depends on the size of data. Well, except for hyperscale, because the different hyperscale architecture means that it always takes just a few minutes to restore any size of database. Then geo restores we know have a longer 1-hour RPO compared to local restores, which will always have the 10-minute RPO. And then we looked at the different restore methods, which include the portal, PowerShell, the CLI, or the REST API. That's it for this lesson. I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson. This is a demo of restoring a database. In this demo, we're going to see how we can find the different backup settings in the Azure portal. We're going to be doing a restore operation of a database with the Azure portal, and we will do a lesson summary at the end. Okay, I'm back in the Azure portal, and the way to find the backup settings is here. We're going to go over here to this left-hand panel and just scroll down, and you'll see here in data management where it says backups. Go ahead and click on that, and we get a list of all the databases in the server with their available backups. And if you want to change the retention policies, you can do so here at the top as well. So go ahead and click on retention policies, and you will see here there's the point in time retention policy, which is the short-term retention, which right now is set to 7 days. There's the differential backup frequency, which right now is set to every 12 hours, and we don't have a long-term retention, so there's no weekly, monthly, or yearly LTR. If you wanted to change the policies for any of these databases, go ahead and select that database and go to configure policies, and right here we can change the point in time restore or short-term retention policy, the differential backup frequency as well. You can see here we can select from 12 hours or up to 24 hours. We can also set that long-term retention using the parameters that I mentioned before during the slides, which was the weekly, monthly, yearly, and specifying the week of year if you want to go with yearly as well. Now if you want to look at the backup redundancy or change it, then you have to go somewhere else, and this one is not that intuitive. You have to go into the specific database. So let's say I want to change that for that T1 database. I will go into SQL databases and then T1, and then here I have to go where it says compute and storage. Go ahead and click on that, and then if you scroll all the way to the bottom, you will find here the option that says backup storage redundancy, and you can see here, for example, that mine right now has selected geo-redundant backup storage, but you could change it to locally redundant, zone redundant, and then apply the change. Now in order to do the restore, I'm gonna go back here into the server page again, scroll down again into data management and backups, and you'll see here where there's an action for each one of the databases that says do a restore. Go ahead and click there for T1, for example, and you'll see here we cannot change the subscription or the resource group or the source database. However, we can change here the restore point, meaning the specific point in time that we want that restore to apply. So for example, I can go ahead and click on the calendar and say I want to restore from yesterday. All right, scroll down and we'll see the portal will automatically give it a name with the name of the database and an underscore with the timestamp. You can say whether you want to restore it into an elastic pool or not. In my case, I'm going to say no. And then you have to configure the compute and storage settings. Now, if you don't change them, you don't have to, it will use the existing settings of the database that you are restoring. So I'm just going to leave it the same. Same thing for the backup storage for that new database that you're about to restore. You can select a different setting at this point. In my case, I'm just going to leave it the same as well. And just go ahead, click on review and create. It'll give you an estimated cost and the summary of all the different settings. And just go ahead and click on create. And now we can see we get the page where it says that deployment is in progress, and it's going to take a few minutes here for Azure to restore that database. And remember, this is a size of data operation. This database in particular is not really big, so it should only take a couple of minutes and we'll have our database copy ready to go. Now the deployment is complete after a few minutes. You can click here where it says go to resource, and we can see we have our brand new database. We can go into the overview and we can see it's right there in the Warner SQL DB server where we restored it. And at this point, you can connect and work with it just like any other database. In summary, in this lesson, we saw how to find the backup settings in the Azure portal, both for the short-term retention as well as the long-term retention. We also looked at where you find the settings for backup redundancy, and then we looked at how you can restore a database with the Azure portal. A very easy operation where you just select the database name, you select the point in time to restore, and then you just have to wait for the operation to complete. That's it for this lesson. I'll see you on the next one. Hello Cloud Gurus and welcome to our next lesson. This is high availability and disaster recovery. In this lesson, we're going to look at the definitions of both of these terms. We're going to look at the high availability models that are built into Azure SQL Database. We're going to look at that disaster recovery options that you have when you use Azure SQL Database. We're going to look at a very cool feature that Microsoft has implemented for disaster recovery called auto failover groups. And we will do a lesson summary at the end. First, let's talk about high availability. This is database redundancy for quick recovery from failures in the same region. This is the critical characteristic of high availability, is that we are dealing with quick redundancy in the same region. Disaster recovery, on the other hand, we are dealing with recovery from failures across different regions. So this is when you have a big disaster or a big outage and one Azure region is completely down and you want to recover your database either with a backup or with a warm synchronized copy in a secondary region. Microsoft has developed two different high availability models, one called the standard availability model and the premium availability model. The standard availability model works the following way. We have a single region, you have a primary replica, and it has SSD storage that only keeps transient data, like TempDB for example. This primary replica is also connected to Azure Premium Storage, and this is where it keeps the permanent data, meaning the data and the log files for the SQL database. Azure keeps track of nodes with spare capacity, and these nodes can also be connected to the Azure Premium Storage if necessary. In the event of a failure, the primary replica can fail over to one of the nodes with spare capacity. The node will establish the connection to the premium storage and reinitialize the SQL Server process. Standard availability is available in the basic and standard DTU tiers. It is also how the general purpose vCore tier is architected. It is based on the separation of compute and storage, so all the permanent data is kept on the Azure Premium Storage. However, the standard availability model can have some performance degradation during maintenance activities and can have longer failover time as the whole SQL Server process needs to be restarted on a node with spare capacity in the event of a failover. The premium availability model works in the following way. We also have a single region. We have a primary replica that has SSD storage, but now that SSD storage keeps both the transient and the permanent data. That means data and log files. Another secondary replica is part of the solution that also keeps transient and permanent SSD data, and there's two more copies of that database as well. So there are three replicas for each primary. Then an always-on availability group is established between all these replicas, so there is synchronization happening, and all of them are writing those log records to their copy of the database at the same time. And in the event of a failure, there's a failover to a machine that's already warm and has the full database copy ready to go. Premium availability is available in the premium DTU tier or in the business critical vCore tier. It is based on always-on availability groups, which is a very core robust feature of SQL Server. It has minimal performance degradation during maintenance activities, and it has faster failover time because we are not restarting SQL Server process on a different node that has to reconnect to premium storage. Instead, we are just changing the connection over to a secondary replica that is ready to receive the workload right away. Premium availability can also be zone redundant, so the replicas will be placed in different availability zones. And finally, premium availability also has the nice feature that you can redirect a read-only workload to a secondary replica. If the cloud region is completely lost, however, then we are not looking at high availability anymore, and we are looking at a disaster recovery scenario. In this case, if you need to do some disaster recovery, You can do it through a backup geo restore, which we discussed in the previous lesson, or you can do active geo replication. Active geo replication is when you have a cloud process that manages cross-region database replicas. Then they can be used for read-only scale and also for failover. So this process happens across cloud regions. Active geo replication is asynchronous. It can support up to 4 replicas. The replica can be in the same or different region, supports read-only queries to the replica, and failover is triggered manually, whether it's planned, where you can let the replicas catch up before switching roles, or unplanned, where you can just force the failover to any of the replicas. Something to keep in mind about asynchronous replication is that it introduces the possibility of data loss across replicas. There is no option to use synchronous replication, and Microsoft has done this for performance reasons. If you want to make a session wait until the current log has been completely replicated, you can use the SP wait for database copy sync procedure. And in this case, your transaction will not continue until the database copies are all synchronized. On top of that geo replication, Microsoft has built the auto failover group feature. You have a primary region with a primary logical server and let's say 3 different databases. Then we have a secondary region with a secondary logical server, and we can do geo replication to have copies of those same 3 different databases, and these can all be unified through a failover group. So if we need to failover from the primary region to the secondary region, all 3 databases can be handled as a unit and failover at once. And the nice thing about this is that the failover group will also get a global name. It will be the name of the failover group .database.windows.net, and then you can connect an application to that name, and the service automatically will handle your connections to go to the primary region, or in the event of the failover, move to the secondary region. Auto failover groups support automatic and manual failover. They only allow 1 secondary region though, so this is a difference to the geo replication, which allows up to 4 different replicas. They do allow multiple groups per server, so if you have many databases, you can create different groups and different configurations of which databases should failover as a unit. They must be created across different Azure regions though, another difference here from active geo replication, which does allow a replica in the same region. Failover methods can be automatic versus manual. In the case of automatic, it is triggered by a region outage that Microsoft detects. You are looking at possible data loss because Microsoft will do a forced failover. The primary as well might be unavailable for an extended period of time depending on the outage. It does have a configurable grace period, like I just mentioned, that you can wait to see if the service will recover before doing the failover. Manual, on the other hand, has to be triggered by an administrator. You can do it with no data loss if you do a planned failover. The primary, if available, can become secondary and start syncing immediately in the other direction. And manual can also be very useful for planned outages or disaster recovery tests as well. To keep track of all this data syncing, there are different geo-replication system views. These include sysdm operation status, which will tell you if all the syncing is working properly, sys.georeplication links, which goes specifically into information for each georeplication link, and sys.dm georeplication link status, which goes into specific status information for each specific georeplication link. Georeplication secondaries are built at full price, so only deploy what you really need. In terms of recovery time objective and recovery point objective, this is how the different options stack up. A geo restore has a recovery time of approximately 12 hours and a recovery point objective of 1 hour. An auto failover group has an approximate recovery time of 1 hour and a recovery point objective of 5 seconds, and a manual planned failover has a recovery time of approximately 30 seconds and a recovery point objective of 5 seconds. In summary, in this lesson we learn about the different high availability options in Azure SQL Database, how we have the standard availability model and we have the premium availability model and the differences between them. We looked at the different disaster recovery options, which include geo-restoring of backups, active geo-replication of databases, and we looked at a very cool feature of the service called auto failover groups, which works on top of the geo-replication, which allows you to failover multiple databases as a group and provides a global name to connect applications that is aware of any failovers and will redirect your applications to the right region. That's it for this lesson. I'll see you on the next one. Hello Cloud Gurus and welcome to our next lesson. This is a demo of configuring an auto failover group. In this lesson, we're going to look at configuring an auto failover group with the Azure portal. We're going to be doing a failover of the group and also a failback to the original region. We're going to look at the client behavior with SQL Server Management Studio during the failover, and we will do a lesson summary at the end. Okay, I'm back in the Azure portal and I'm here on the page for the SQL Server that I want to be the primary of the failover group. Here on the left hand panel, we'll scroll down to the data management section and you'll see where it says failover groups. Go ahead and click on that and you'll see I don't have any group created, so we'll go ahead here and click where it says add group. Now I'm gonna give it a name. I'm just gonna name it tdbs.database.windows.net. Then I have to select the partner server for this server. I already pre-created one before the demo called Warner SQL DB Server 2. Now Warner SQL DB Server 2 is actually placed in West US 3 and the primary here is in East US. Now the read-write failover policy can be either automatic or manual. If you leave it for automatic, you need to select the read-write grace period. In this case, it's an amount of hours that the database is unavailable before Azure triggers the automatic failover. Now for the intent of doing the demo, I'm gonna set it to manual failover so we can see how the whole thing works. Now finally, we have the option here of selecting the databases that are gonna be part of that group. So I'm gonna click here on configure database and I'm gonna select the two different T1 and T2 databases that we created previously during the course as part of this auto failover group. Now notice how the monthly cost is quite higher than it was before because these are serverless databases, but the moment that I enable the auto failover group, they are not going to be able to be auto shut down. So that's something to keep in mind if you are using a lot of serverless. If you want to add them to a geo replication or do an auto failover group, they will get built as regular databases. Now in this case, of course, I'm expecting that. So go ahead and click on select and then go ahead and click on create. Now we'll see here the deployment has succeeded. I can go ahead and click on refresh here on this page and we see we now have that failover group. It shows the primary server, the secondary server, the read-write failover mode, and the database count. So I have 2 of the 4 databases in that server as part of this TDBS failover group. I can go ahead and click on it, and I get this nice GUI that shows me what's happening and what is the actual geographic distribution. So you can see here, we can see that it is currently seeding the databases, so it's doing the initial copy, and that it is doing the East US as the primary region over to West US as the secondary region. We can see here at the top, we can add databases to that auto failover group. We can edit the configuration, we can remove databases, and once the databases are seeded and they are in sync, we will be able to do a failover or a forced failover or delete the auto failover group. So I'm gonna wait here for a few minutes and we'll come back once the copies are in sync. Okay, so after a few minutes, we can see now that the auto failover group is in sync. We can see the configuration details, databases within the group We can see T1 and T2, they are both online and on the secondary server. Now they are both readable as well. So it says database is selected to be added. In this case, we don't have any, and we don't have any selected for removal either. Now let's go back into the configuration details. And what I'm going to do now is show you here on Management Studio. I have already pre-connected it, and we can see here I'm connected at the top to tdbs.database.windows.net. So I'm not connected to the logical server name. I'm connected to the auto failover group. And we can see here, if I wanted to, I can run a query to that T1 database. It runs just fine, retrieving a couple of records, and it's done through the connection of the auto failover group. Now this is what we're going to do. I'm going to increase this number so that it will continuously keep running that query. Then we're going to go back into the Azure portal and we're going to do the failover. So let's get going. I'm going to start executing there, and it's going to keep running. Switch back to the portal, and I'm going to do a failover. Now you'll see this warning that says this will switch all the secondary databases to the primary role. All TDS sessions will be disconnected. All new TDS sessions will be rerouted to the secondary server. We can say yes. And now this is going to start triggering the failover group, failover, and it will switch between east being the primary and west being the secondary to the other way. West will be the primary and east will be the secondary. And now we can see here at the top it says failover group failover succeeded. And if we look at the diagram, we can see that now west shows as the primary and east shows as the secondary. And what happened with our Management Studio query? Well, if you look here at the bottom, we can see that Management Studio already has retry logic built into its connection, so it automatically just repointed into the secondary. And here this connection, that's to TDBS, we can try to refresh it. And now, if we open here where it says databases, we will see that we don't see the other two databases that were part of the initial logical server. The ones that are not part of the auto failover group didn't get failed over to the West US region. And so when we do the connection now to tdbs.database.windows.net, we only get those two databases, T1 and T2. Now, if we wanted to just do a failback again, we just have to do the failover again. Go ahead, say yes, and this will fail over the group back to East US being the primary and West US being the secondary. And you will have the same behavior in terms of the client applications. In summary, in this lesson, we looked at the configuration of an auto failover group. It's an intuitive GUI that shows the region availability for your replicas. We executed a failover and failback, and this is a process that is handled automatically by Azure, and it takes care of coordinating the changing roles from primary to secondary and vice versa. We also observed the client behavior with SQL Server Management Studio, where there is a short interruption during the role change, and this is why it's critical that applications implement retry logic to deal with these type of transient disconnections. That's it for this lesson. I'll see you on the next one. Hello Cloud Gurus, and welcome to our section summary. First lesson that we saw in this section was backup capabilities. We looked at some of the backup fundamentals, such as the fact that backups have been automatically triggered by the service. We looked at the default schedule of the backups. We looked at the short-term retention maximum values for the backups. And we looked at the backup cost for DTU and vCore based tiers. We also looked at the options for backup redundancy, including locally redundant storage, zone redundant storage, and geo-redundant storage. Finally, we looked at long-term retention, which is configurable for up to 10 years and uses Azure Blob Storage for keeping those long-term backups. Finally, we also looked at the different retention policies that you can apply for long-term retention. Next lesson was performing restores. We looked at the different restore options, such as doing a local restore, doing a geo restore, and the time span of a restore. We look at how it depends on the size of data and how hyperscale is the exception because of its different architecture. We also discussed how geo restores have a longer 1-hour RPO compared to local restores, which have a 10-minute RPO recovery point objective. We then looked at the different restore methods, which include the Azure Portal, PowerShell, the Azure CLI, or the REST API. Next lesson, we did a demo of restoring a database. We looked at where to find the backup settings in the Azure Portal, which include the short-term retention as well as the long-term retention and the backup redundancy. Then we did a restore of the database with the Azure Portal. We selected a database name, a point in time to restore, and then we just let Azure do its own automatic restore process. In the next lesson, we discussed high availability and disaster recovery. We looked at high availability and how there's a standard availability model as well as a premium availability model and the differences between the two of these. We then looked at the disaster recovery options, which include the geo restore of backups, active geo replication of databases, and a very cool feature known as an auto failover group, which allows you to failover multiple databases as a group and provides a global name to connect applications that automatically will repoint the application to the active region. Then we did a demo of configuring an auto failover group. We did it through the intuitive GUI that Azure has that shows region availability. We executed a failover and failback. Azure took care of coordinating the changing roles from primary to secondary and vice versa. Then we observed the client behavior with SQL Server Management Studio, how there is a short interruption during the role change, and how applications need to implement retry logic so that they can deal with these type of transient disconnections. Join me on the next section as we look at migrating to and from Azure SQL Database. Hello Cloud Gurus, and welcome to the next section in our Managing Azure SQL Database for SQL Server DBA's course. This is your introduction to migrating to and from Azure SQL Database. In this section, we are going to look at a migration methodology that I recommend you follow when you take over a project to migrate from SQL Server to Azure SQL Database. Then we'll look at the different migration tools available to perform the migration and the different characteristics for each one of them. Then we'll do a demo of migrating with the Microsoft Data Migration Assistant. We will also do a demo of migrating with SQL Server Transactional Replication. Then we're going to talk about moving back from Azure SQL Database to SQL Server. We will also do a demo of migrating back to SQL Server, and we will do a section summary at the end. Some of the topics that we will cover in this section include migration steps to follow and recommended testing that you should do, Data Migration Assistant as a great tool for assessments and one-time migrations, Database Migration Service, which is a cloud service that Microsoft has created in Azure. We're going to look at importing data back to SQL Server if you find the need to go back to the SQL Server product, and much more. Are you ready? Let's go! Hello Cloud Gurus, and welcome to our next lesson, Migration Methodology. In this lesson, we're going to look at that migration preparation steps that you should take before starting the project. We're going to look at that success criteria that migration projects usually have. We're going to look at the steps that you should follow for migration testing. We're going to look at planning for downtime while you do the migration. We're going to look at the 5 questions you need to answer before you start your migration project, and we'll do a lesson summary at the end. Let's look at the migration preparation steps. First, you want to identify the source database that is a good candidate for migration into Azure SQL Database. Then you want to identify the service benefits that you are trying to get from this migration. Why are you trying to do this? Then you want to identify any showstoppers that might be stopping you from executing the migration. Then you want to identify the service model that you're going to use in the cloud, such as DTU or the vCore model, whether you're going to use provisioned or serverless. Then you want to identify the proper service tier. Let's say, for example, in the vCore model, select between general purpose, business critical, or hyperscale. Then identify the region that you're going to use, or regions if you are going to be using something like auto failover groups, which we saw in the previous section. Then finally, identify your SLAs that you need to satisfy during the migration to determine the best method to minimize that downtime. You also want to establish very clear success criteria for your migration project. You want to make sure that your downtime SLA is upheld during the migration. You want to make sure that your application has no issues after it's being migrated. And you want to make sure that your database has good performance once it's migrated into Azure SQL Database as well. Usually these are the 3 key success criteria that at a minimum every migration project has to satisfy. A migration also has multiple testing phases. We will start by doing application functionality testing against Azure SQL Database. Then you would do database performance testing to make sure that there are no degradations by moving into Azure SQL Database. And you also need to do a migration downtime testing. Perform a dry run of your migration method. Measure how much time it takes to move the data to the cloud so that you have an accurate measurement of the downtime. Application testing follows this workflow. First, you have to test all your different application features with a copy of the application that is working against Azure SQL Database. Then, if you identify any issues, then you have to go back into switch the service tier if it is an issue with a feature that is not available on a particular service tier, or refactor your application to remove that particular limiting feature. After you've done that, you gotta go back and test again the application, and at this point, if there are no application issues, you can move on to performance testing. In the performance testing phase, you want to start by measuring your workload performance against Azure SQL Database. If it is too slow still, then you want to go back to the drawing board and then increase resources, tune the SQL, or look into the architecture that you're using and see if there's anything that you can do to improve it. After you've done any changes, go back to measuring your workload performance. And if it's not slow anymore, then you can move on to plan your migration cutover. For your migration cutover, you need to plan for downtime. This is the time that your application will not be available while the database is being migrated. You have to test and time the migration method that you think you're going to use. And then if there's an issue with the SLA, the availability of that application, meaning your downtime is too long, then you got to go back to the drawing board and switch method to a different migration method with less downtime. Then do it again, test and time the migration method, and if there are no issues anymore, then you move forward with scheduling that migration. Before you embark on a migration project, you have to make sure that you can answer the 5 questions. What are you migrating? You identify the databases or the SQL Server instances that you want to bring to the cloud and make sure that they are good candidates for bringing them to the cloud. Why are you migrating? What is the tangible benefit that you want to get out of moving these databases out from SQL Server into Azure SQL Database? Where are you migrating? You have to select the regions, you have to select the service model, and you have to select the service tiers. How are you migrating? You have to select also a migration method that will meet your downtime SLA. And finally, when are you migrating? Once all the chips are lined up, you can schedule the downtime with your business and put that migration on the production calendar. In summary, in this lesson, we talked about the preparation steps for a migration, which include identifying all the service details that you're going to use, identifying your SLAs for your downtime, and then you can move on to migration testing. And this includes application testing, performance testing, and planning for downtime. And you want to select a migration method that meets your SLAs for availability, as well as make sure you can answer the 5 questions about what, why, how, where, and when you're executing your migration project. That's it for this lesson. Thanks for watching. I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, Migration Tools. In this lesson, we're going to look at the tools available to migrate to the service. we're going to look at the options for doing short downtime migrations. We're going to look at the migration go-live steps that you will follow to switch from SQL Server to Azure SQL Database, and we're going to do a lesson summary at the end. A very important thing to realize when you're planning to migrate from SQL Server to Azure SQL Database is that Azure SQL Database does not currently support a direct restore of a backup file from SQL Server. Now, Azure SQL Managed Instance does support it, so if this is important to you, you might want to revisit selecting Azure SQL Database as your target service. However, if you are moving to Azure SQL Database, you do have a lot of other migration tools available. You can do a manual export and import of a backpack file. You could do the Microsoft Data Migration Assistant. You can also use the Azure Data Studio SQL Migration Extension. You could use the Azure Database Migration Service, and you can even use SQL Server Transactional Replication. Now let's break each one of these down. First, manual export and import. This takes longer downtime because you will need to start the export once your application is no longer using the database, and your application will not be able to resume until the import has completed into the cloud. It only takes care of data movement, so there will not be any sort of assessment to tell you whether there are any blockers or issues with your migration. You'll have to do one database at a time, unless you do some sort of scripting on your own. But it's a pretty useful method for small databases, and it just gets the work done. Larger databases will likely not be a good candidate for this method unless you can afford the longer downtime. Microsoft also has its own tool called the Data Migration Assistant. This is an official Microsoft tool. It has assessments and can also do the data movement, so it covers two of those angles. It can do offline migration of databases. By offline, this means that the application will have to be stopped for the whole entirety of the database being moved into the cloud. The Migration Assistant only supports one database at a time as well, and it runs completely independent in the host machine where you install this Data Migration Assistant. So this is a good thing because it has no other dependencies other than the machine and the tool itself. Azure Data Studio also has a SQL migration extension. This again is an official Microsoft tool. It does the assessments as well as the data movement, just like the Data Migration Assistant. It offers offline migration of databases, just like the Data Migration Assistant as well. It can do multiple databases at once, so that's pretty handy if you have a group of databases that you want to migrate in one project. And it uses Azure Database Migration Service behind the scenes. So there's a big difference between the Data Migration Assistant and the Azure Data Studio SQL Migration Extension, which will require you to have an Azure account and the use of an Azure service to complete the migration project. Azure itself has a database migration service too. This is an official Azure service, so it's also an official Microsoft tool. It does data movement only though. It does not do the assessments. You will have to do the assessment in one of the other two tools I just mentioned. It does offline migrations of databases as well. It can do multiple databases at once, but it has its own cost and billing to be able to use this database migration service. Then we have SQL Server Transactional Replication. This is a SQL Server 2012 Plus feature, so it has been available in the product for quite a while. It is for data movement only. There's no assessment stage done in this particular product. It does an online migration of the database. So you move most of the data, and then transactional replication will keep the source database and the target database in sync, so that when the time comes for the migration cutover, it is a very short pause for your application, and that's why it's called an online migration. It has shorter downtime because of this functionality. It can do multiple databases at once if you set up multiple publishers and multiple subscribers, and it can be done graphically with SQL Server Management Studio. If you need to execute a short downtime migration where your application can be unavailable only for a short period of time, then transactional replication is your best bet to do a quick failover and short downtime migration from SQL Server to Azure SQL Database. Replication to Azure SQL Database is established by enabling the SQL Server publisher, applying the snapshot to Azure SQL Database, and then continuously data is synced through a push subscription from SQL Server to Azure SQL Database. Once you have your migration date on the calendar, during the go live, you will stop the application, verify it's not writing any more data into the database. Then you can verify that all the data is now in the cloud database. You would reconfigure the application connection to point to the cloud database, and then resume the application and verify that everything is working. In summary, in this lesson, we looked at the different migration tools available, like manual export and import, the Microsoft Data Migration Assistant, the Azure Data Studio SQL Migration Extension, the Azure Database Migration Service, SQL Server Transactional Replication. We discussed the options for a shorter downtime migration done through transactional replication with the SQL Server Publisher and Azure SQL Database as the subscriber, the process to establish that replication, and the go-live steps that you would follow on the day of the cutover. That's it for this lesson. Thanks for watching, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson. This is a demo of migrating with the Microsoft Data Migration Assistant. In this lesson, we're going to look at creating a new migration project with the Microsoft Data Migration Assistant. We're going to look at running a migration assessment to evaluate the readiness of a SQL Server database to Azure SQL Database. We're going to run a schema and data migration, and we'll do a lesson summary at the end. Okay, I have the Data Migration Assistant open, and the first thing we're going to do is use new right here to create a new migration project. So I'm just going to call it demo. And in the assessment type, I'm going to leave database engine. You also have the option of doing integration services in case you are using SSIS. And the source server is going to be SQL Server, and the target server, you can see there are different options here. There's Azure SQL Database, Azure SQL Database Managed Instance, SQL Server on Azure Virtual Machines, or another SQL Server. In our case, I'm going to leave it here for Azure SQL Database, and just go ahead and click on Create. Then we need to select the type of report that we want, check for database compatibility, as well as checking for feature parity, and I recommend you leave those two selected. Click on Next, and now we gotta select the source. In this case, I'm going to select the local host where I have a SQL Server already installed, and just press on Connect. Now I have the databases in that SQL Server. I'm gonna go ahead and click on it. You also have the option of providing extended events or traces to be assessed in case that all the code is not inside your database. Then go ahead and click on Add. And at this point, you are ready to just press Start Assessment. Now you see here we got a warning, for example, that our SQL instance has some SQL Server agent jobs, and these are not available in Azure SQL Database. So it is up to you to decide what you're going to do, whether this is an actual showstopper, whether you want to move into Azure SQL Managed Instance, or you want to abandon your migration project. You have the option here to save the assessment as a DMA file. You can export the assessment as well as a JSON file, or you can restart or delete the assessment as well. You also have an option here at the bottom to upload to Azure Migrate. If you are using the Azure Migrate service, then you can store the results of the assessment there in that service as well. In our case, we identified that while this is not ideal, this is not really an issue or a showstopper that has to do with the actual database, so we are going to continue moving forward. We can also check compatibility issues here with the VentureWorks LT and Azure SQL Database, and we can see there are no compatibility issues with this particular database right now. We can go back and create a new project. This one is going to be a migration project. Go ahead and give it a name. This time it's going to be called Demo Migration. Select Source as SQL, target as Azure SQL Database, and we want to migrate both schema and data. Then go ahead and click on Create. For the source server, we're going to select the same local host, connect to it, select the source database, then click on Next. And then for the target, we're going to go ahead and use that cloud database that we've been using. I'm going to use SQL authentication to connect to it and enter my credentials and press connect. And we can see here I have the AdventureWorks LT database pre-created in Azure SQL Database. You have to pre-create the database that you're going to migrate into. This database is empty right now. It has no tables at all. Go ahead and click on Next. And now we can see all the different objects available for migrating from the SQL Server into the Azure SQL Database. In our case, we want to migrate everything, so we're going to leave everything checked and then just press Generate SQL Script. Here, you can save the script that the tool has generated, or you can copy it to a different tool. And if you're happy with it, you can go ahead and press Deploy Schema. You can see here at the top where it says 383 commands executed with no errors. You can also export this output if you want to and save it in your local system. And then once you're happy with the schema, you can go ahead and press on Migrate Data. At this point, you will get a list of the different tables that are in the source database and their row count and whether they are ready to move. Here we can see that all of them are ready to be moved right now. There are no pending issues with any of these tables. So we can go ahead and click on Start Data Migration. And we can see the migration has been successful. All the 12 tables have the successful sign and we don't have any pending issues. At this point, the only option we have is to delete the migration in terms of the migration assistant. And here I have Management Studio connected to the Warner SQL DB server that was our target server. I can open the databases node and we can see we have our AdventureWorks LT database. Most importantly, we can see all the tables made it through, as well, for example, as the different store procedures that were part of the database, so we didn't miss on any objects. And we can select from the table and we can see and verify that indeed there is data there that was migrated through the tool with no issues. In summary, in this lesson, we saw the Microsoft Data Migration Assistant in depth. We looked at the Windows GUI migration tool. We looked at running assessments of compatibility between SQL Server and Azure SQL Database. We looked at migrating both the schema and the data into the cloud. And we migrated from SQL Server to Azure SQL Database. That's it for this lesson. Thanks for watching. I'll see you on the next one. Hello Cloud Gurus and welcome to our next lesson. This is a demo of migrating with SQL Server transactional replication. In this lesson, we are going to look at using SQL Server Management Studio to set up the replication. We're going to verify that the database is in sync. We're going to follow the migration go live steps and we'll do a lesson summary at the end. Okay, I'm in SQL Server Management Studio and I'm connected to my local SQL Server on this machine and I have the AdventureWorks LT database already in this SQL Server. What we're going to do is we're going to set up transactional replication to Azure SQL Database so that we can do a short downtime migration. So first, let's set up the replication. So let's go down to replication and we're going to do a new publication. So first thing is creating a publication of what we want to move into the cloud. In this case, we just have that AdventureWorks LT database. Go ahead and click on Next. And we want to start a transactional publication. Go ahead and click on Next. And we want to select all the objects that we can to publish. Go ahead again and click on Next. We just get a few warnings here about the dependencies, which are not really a blocking issue because we are right now going to publish everything. So we'll go ahead and click on Next. We don't need to filter data from our publication either. Now we need the snapshot agent in order to create the first snapshot movement of the data. So we'll just go ahead. In this case, I'm going to select to create a snapshot immediately and keep it available to initialize subscriptions. Then we have to select the security settings for the different replication agents. I'm just going to run it under the SQL Server Agent Service account. Say OK, click on Next, and go ahead and create the publication. We have to give it a name, and we're just going to call it AdventureWorks LT Pub. And click on Finish. The process has completed. I can go ahead and close this. And if I open up the replication node here in Management Studio, and we can see the publication there has been created. Now the next step is to go ahead and do a new subscription. So we're in the new subscription wizard. Go ahead and click on Next. The publisher, we just have to select the publication that we are going to create the new subscription for. In this case, we only have the AdventureWorks LT Pub 1. So go ahead and click Next. In this case, for Azure SQL Database, you have to run it as a push subscription. You can't run it as a pull subscription. So we'll leave that option selected for push. Now I'm going to add a subscriber, and I'm going to connect to my Cloud SQL Server. Go ahead and click on Connect, and we can see I already have the AdventureWorks subscription database ready to go. Go ahead and click on Next, and now we have to set the security options to connect to the distributor as well as connecting to the subscriber. Now to connect to the distributor, I'm just going to set it to run under the SQL agent for demo purposes, and to connect to the subscriber, I am going to set my credentials, and then go ahead and press OK. Now we are ready. Go ahead and click on Next. And then we have to set the agent schedule. In our case, we're trying to do a short downtime migration, so we're going to leave it here with the option of running continuously. Press Next. In this page, we're going to tell the wizard that we want to initialize that database, and we want to initialize it immediately so that it applies the snapshot coming from SQL Server to Azure SQL Database as soon as the wizard is over. Press Next. Now we have the option here to create the subscription. Go ahead and press Next. We'll see all the different choices that we made in the summary, and go ahead and click on Finish. And we can see here we have success on creating the subscription and starting the snapshot agent. Now let's go and verify on the cloud side what is happening. We're going to close this out. Then we're going to connect now to the Cloud SQL Server. And if we open the database here in the cloud connection, we can see that the tables are replicated now between the on-prem SQL Server and the Azure SQL Database version of this AdventureWorks LT database. Now let's verify that the data is being synchronized. Let's go back to the top. We're going to open this AdventureWorks LT, the on-prem one, and let's do an edit of one of the customers. So we're going to select the customer that has customer ID 1, and we're going to set the first name from Orlando. Let's just switch it to Alex, for example. So now the change has been committed by the GUI. Go ahead and close this, and let's see what's happening in the cloud copy. I'm going to move ahead to customer on the cloud table, and then select top 1000 rows. And we can see right away here customer ID 1, first name is Alex instead of Orlando. So we can see in just a matter of a few seconds the change was propagated from the SQL Server on-prem database to the Azure SQL database that has the same contents. Now, when it is time to do the cutover, what you should do is stop your application from writing any more changes to the database. Then go back to your on-prem SQL Server, go to the properties, go to the options, and you scroll down here to the bottom. You'll see the option where it says database read only. Now I recommend that you set the database to read only so that you know for sure that nobody else is modifying your database before you do the cutover. So go ahead and change this to true and say OK, and this will close all the connections to the database to change the status. Say yes. Now at this point your on-prem database is read-only. You can go ahead and redirect your application to your cloud copy, test it, and if everything works out well, you can go back to your on-prem SQL Server and eliminate the subscription and the publication, and eventually take the database completely offline. In summary, in this lesson, we did a migration for its SQL Server transactional replication. We used the SQL Server Management Studio replication wizard, and again, this is a schema and data movement only process. It does not have assessments built in. We did the migration and we verified the copy. We followed the go live steps to switch from SQL Server to Azure SQL Database to show what operations you would do in the scenario of a real application migration. That's it for this lesson. Thanks for watching. I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, moving back to SQL Server. In this lesson, we are going to look at the reasons why you might want to move back from Azure SQL Database into SQL Server. We're going to look at the methods available to move back. We're going to do a lesson summary at the end. The first thing to realize is that Azure SQL Database does not lock you into the service forever. You can always migrate back to SQL Server if you feel you have to. Sometimes it might be that you're hitting some sort of service limit and you need some particularly special hardware. It might be that you're moving to a different environment, for example, a different on-premises data center, or it might be that you need a missing feature that is simply not available in Azure SQL Database. If you need to move back to SQL Server, you can do an export and import of a backpack file with the contents of the database. You can use Azure Data Sync, which we covered in a previous section, or you can use an ETL tool to extract all the data and load it up into a different database. The manual export and import is a very simple method, but it takes longer downtime since you have to stop all the applications connecting to Azure SQL Database and then run through the whole process. Azure Data Sync requires more setup and configuration between the cloud and the target database server. It also requires triggers at the source Azure SQL Database, which can hamper performance if you have a really high volume, high throughput application, but it does have shorter downtime as it keeps both Azure SQL Database and the target SQL Server in sync. Using an ETL tool like Azure Data Factory, for example, requires more setup and configuration, but it can be customized to do anything. You can select to migrate only some tables, you can select and migrate the entire database. It can support offline or online migrations as well, depending on the source database and whether you have something like change data capture available. The key to select the right tool to move back to SQL Server, find out what is your downtime SLA, and select the best tool to support it. In summary, in this lesson, we talked about the reasons to move back to SQL Server, whether you're hitting a service limit, migrating to a different environment, or you need some missing feature in the service. And we discussed the methods to move back, such as an import and export of a backpack file, using Azure Data Sync to keep Azure SQL Database and a SQL Server database in sync, or creating a custom ETL process. And at the end of the day, it all boils down to your downtime SLA, and you have to select the best tool to support that SLA. That's it for this lesson. Thanks for watching, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson. This is a demo of migrating back to SQL Server. In this lesson, we're going to export a backpack file from Azure SQL Database. Then we're going to import the backpack file into SQL Server. We're going to verify the data, and we'll do a lesson summary at the end. Okay, so the way that we're going to do this is we have two different scripts. One that is called export from Azure SQL DB that we're going to use to export the data out of Azure SQL Database into the folder here in this local machine. And then we're going to do import to SQL Server through another script that will read off of that backpack file and import it into SQL Server. And then we're going to compare row counts at the end. So let's look at the contents of the first script. The first line here will set the script to the directory where the SQL package has been installed. Note here in the references for this lesson, I will add the download link for the SQL package utility. And then in the next line, we say the source server name, in this case, is our Azure SQL Server, called Warner SQL DB server. Then we have the source database name. In this case, it's AdventureWorks LT. Source encrypt connection is true, since we need to do a secure connection to the cloud. Then we're going to set the target file is going to be the folder in the local machine where the file is going to be saved. Then I have to provide the source user and the source password to connect to that source cloud database. And then at the very end, this command is just to simply change the context of the command line back to the originating folder where we are going to be running this script. So I'm going to close this out. I'm going to replace the credentials for the right credentials, and I'm going to run the script now. So I'm here in the command prompt, and I set myself to the folder where I'm keeping all the demo files, and I'm going to go ahead and run that export from Azure SQL DB.bat file that we just went over. Now we can see it starts to extract the schema from the database, then it's going to extract the data from the database, and it's all going to be written out into our local folder. Now, if I look right behind of that command line window, we can see where we have our backpack file now that was correctly generated with the SQL package utility. Now, let's go ahead here and clear the screen. And let's go and check out the import to SQL Server batch file and look at the contents of that. So this is very simple. Again, we're going to change the directory to where the SQL package is. And now the action is going to be to import instead of export. The target server name is going to be our local host SQL Server. The target database name is going to be AdventureWorks LT. And the source file is going to be the backpack file that we just wrote with the previous script command. So we're going to go ahead. And the name of this one is import to SQL Server. And we can see it is importing the schema and the data into the database. It has written the tables and it has enabled the indexes. Now at this point, an easy way to validate that both the source and the target are the same is to do some comparison of row counts. So let's go into SQL Server Management Studio and do just that. Here in SQL Server Management Studio, I'm connected to both the cloud copy as well as the on-prem copy. So I'm going to go ahead and have a new query ready. In the download package, I have a query for doing row counts. We're going to take that query and bring it over and execute it. And we get the row count of all the different tables in the AdventureWorks LT database. Now I can do the same thing here. Refresh the databases on my on-prem SQL. We can see AdventureWorks LT is there now. Do a new query. Use the exact same query. And we get the row counts as well. And you can even do this with the vertical tab if you want to just do a quick validation visually of the different row counts. We can see here they're all exactly the same. If this was a larger database where you have hundreds or possibly thousands of tables, then you could easily script this comparison as well. After you generate the row counts, you could have a PowerShell or a batch script that will compare based on the table names and verify that all your row counts are the same as well. In this lesson, we looked at migrating back to SQL Server, and we used SQL package.exe to export from Azure SQL Database into a backpack file. Then we used that same tool to import the backpack file into SQL Server. Then we verified row counts between the two databases to make sure that all the data made it through. That's it for this lesson. Thanks for watching, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our section summary. In the first lesson, Migration Methodology, we looked at the preparation steps for a migration, which include identifying the service details, identifying your SLAs, and then doing migration testing, which includes application testing, performance testing, and planning for downtime, where we look at selecting a migration method that meets your SLAs and make sure you can answer the 5 questions as to what, how, why, when, where your migration is going, so that you're always well prepared to take on such a project. On the next lesson, we looked at the migration tools. For example, we have the manual export and import, the Microsoft Data Migration Assistant, the Azure Data Studio SQL Migration Extension, the Azure Database Migration Service, and SQL Server Transactional Replication. And we looked at shorter downtime migrations, which can be done through transactional replication, and we looked at the process to establish this replication from SQL Server to Azure SQL Database. Finally, we looked at the go-live steps for a migration project. In the next lesson, we did a demo of migrating with the Microsoft Data Migration Assistant. This is a Windows GUI migration tool. It runs assessments of compatibility as well as migrating both schema and data. And we migrated from SQL Server to Azure SQL Database. The next lesson, we did a demo of migrating with SQL Server transactional replication. In this case, we used SQL Server Management Studio for its replication wizard. Then we did the schema and data movement only process. This particular tool does not offer assessments. Then we did the migration and verified the copy. And we followed the go-live steps to switch from SQL Server to Azure SQL Database, just like you would do if you were migrating a real application. In the next lesson, moving back to SQL Server, we discussed the reasons to move back to SQL Server. Could be because you're hitting some service limit, you have to migrate to a different environment, or you need some specific missing feature. We also looked at the methods to move back, which include import and export of a backpack file, using Azure Data Sync, or creating a custom ETL process. And we mentioned that the right tool will depend on your downtime SLA. In the next lesson, we did a demo of migrating back to SQL Server. And this time, we did it through SQLpackage.exe to export from Azure SQL Database into a backpack file. And then we used that same tool to import the backpack file into SQL Server. And then finally, we verified that the row counts are the same between the databases to make sure that the migration back to SQL Server did not lose any data in the process. Join me on the next section as we look at monitoring and tuning Azure SQL Database. Hello Cloud Gurus, and welcome to the next section in our Managing Azure SQL Database for SQL Server DBA's course. This is your introduction to monitoring and tuning Azure SQL Database. In this section, we're going to look at Azure Metrics Alerts. What type of metrics can you track? What sort of alerts can you generate? Then we're going to do a demo of creating database alerts with the Azure portal as well as the Azure PowerShell. Then we're going to look at performance system views that are built into Azure SQL Database. And then we will do a demo of tracking performance with those system views. Then we will look at Azure performance tools that are built right into the portal to help us debug, troubleshoot performance issues. And we will do a demo of reviewing performance and recommendations in the Azure portal. Finally, we will do a section summary at the end. Some of the topics that we will cover in this section include some of the database metrics that Azure collects. We look at Azure alerting, the different components of an alert, and what sort of alerts you can generate. We will look at the performance views that allow you to track the different characteristics of a workload in Azure SQL Database. We will also look at the portal features that allow you to understand what is happening behind the scenes in your database and what recommendations you can get automatically from Azure, and much more. Are you ready? Let's go! Hello Cloud Gurus, and welcome to our next lesson, Azure Metrics Alerts. In this lesson, we are going to cover monitoring and metrics in Azure SQL Database. We will look at alerting basic concepts so that we all understand and get on the same page on the basic ideas. Then we're going to look at the alert creation process that you can follow to create an alert. And we will do a lesson summary at the end. Monitoring of your Azure SQL Database is still very much your responsibility, and as a DBA, you have to make sure that you have the proper monitoring to guarantee the proper performance of your database. Azure allows you to specify different sources to monitor and to potentially alert on, such as the resource health that Azure tracks automatically from your service, the service logs that your service generates that you can then query to generate an alert, and the service metrics that Azure constantly measures that you can also evaluate and generate alerts depending on different situations. Metrics are tracked on different categories, such as connectivity, performance, or database usage. Connectivity metrics include metrics such as how many connection attempts were blocked by the firewall, how many failed connections did you have, or how many successful connections are happening. Performance metrics include DTU percentage, DTU limit, or DTUs used if you're on the DTU model, or CPU percentage, log IO percentage, or data IO percentage. All those work both on the DTU model or also on the vCore model. And we also have some database usage metrics like deadlocks, sessions percentage, so how many sessions are close to the capacity of your particular service tier. We have the total database size, so you can trend and plan by looking at how your database size has been changing over time. You have the database size percentage as well, so that you can track it against any sort of max limit that you have set. And you have workers percentage as well to keep track of how many threads you're occupying. And you have in-memory OLTP storage percentage if you're using premium on the DTU model or business critical on the vCore model. This is how the alerting process goes. We have the database, and during its operations, the database generates different signals. These signals get evaluated against an alert condition. If not, so the signal measurement does not meet the threshold set in our alert, then we just go back to the main loop and keep looking and evaluating the signals. If it does meet the threshold for the condition to alert, then it executes the alerts action group. Alert conditions evaluate the signal and decide whether to trigger the alert or not. Alert conditions can be metric values reaching a particular threshold that you set, or a threshold that is automatically generated by Azure through dynamic alerting. It can also be a resource health entering a specific status, for example, if your database is now unavailable, or it can be a log record matching an event of interest, for example, if a database gets deleted. Action groups define who receives the alerts and how they are delivered. And we will look at the different options for the type of alerts to generate in the demos coming up. Alert definition is done through the following steps. We select a signal, which again could be a metric, could be a log record, could be a resource health event, and then we define a condition, which can be less than, less or equal than, greater or equal than, equal or different to some particular threshold or status. So we select that threshold or status that we are going to evaluate against the condition. Then we select a period of time that this condition must evaluate to true. And then we select what action to trigger when that condition becomes true. And using this framework, you can monitor and alert on all the necessary operations and scenarios that you need to follow to guarantee the health of your database. In summary, in this lesson we discuss monitoring basics, such as how it is still a DBA responsibility and the service, while it gives you all the tools, is not gonna create the monitoring alerts for you. Then there's different monitoring sources like the metrics, the logs, and the resource health. We have the metrics divided into connectivity metrics, performance metrics, and database usage metrics. Then we looked at the alerting and how it starts by generating signals. The signals get evaluated against the condition. Then the condition, when met, goes into an action group, and this will define who receives the alert and the type of alert. Finally, we looked at the step-by-step process of creating an alert. That's it for this lesson. Thanks for joining me. I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson. This is a demo of creating database alerts. In this lesson, we are going to look at the metrics that are available in the Azure portal and how to find them. Then we're going to look at creating an alert in the Azure portal. Then we're going to look at creating an alert with PowerShell. And we're going to be doing the testing of the alert by generating a workload that will trigger the alert. And we will do a lesson summary at the end. Okay, I'm connected to the Azure portal and I am on the AdventureWorks LT database page. Now the first thing we're going to do is go over to the metrics page so you can see where you can find all the metrics and their values. So right here on the left hand panel where it says monitoring and metrics, and then here we already have pre-selected the scope of the database, the metric namespace, and now we have the list of all the metrics available. In this case, let's select the metric like CPU percentage, and then you have the different aggregations that you can apply to that metric. For example, I can select instead of the average to do the max or to do the min. I'll leave the average right now. And then the other thing that you can adjust here easily is the time range of your chart. So right now here it says last 24 hours, but for example, I could say instead just the last 4 hours. Go ahead and we'll see I didn't have any activity over the last 4 hours. Let's say for example the last 12 hours, and we can see some spikes here of activity in the database in the last 12 hours. Now if you find a metric that you want to create an alert on, there's an easy way to do it right here on this page. There's a button right here that says new alert rule. We're gonna go ahead and click on that button, and it will pre-select the metric that you want. So you see here it says CPU percentage. Now we have to decide what the alert logic is going to be. The threshold can be static or dynamic. When it's static, then you have to set the exact threshold value. When it is dynamic, then you don't set the threshold value. Instead, you set the threshold sensitivity to either medium, high, or low. In this case, Azure is the one that's going to decide when to trigger the alert based on some machine learning that it does on the behavior of your database. Now I'm going to go back to static so that we can control exactly when the alert gets triggered. Especially important for demo purposes, but you might want to consider if you want to do static or dynamic depending on how much control you want to have over the alerting of your database. So in this case, we're going to say aggregation type. We want to monitor the average CPU percentage, and we're going to generate an alert if it's greater than 60%. Now it's going to say when to evaluate, and it set the default here to 5 minutes. However, I'm going to make it more aggressive and say I want to check every 1 minute, and the look back period is going to be 1 minute as well. So every minute we're going to be checking whether the last minute that just passed had the 60% CPU as the average. Now it shows you a preview here of the activity. Now in my case, for my database, there hasn't been that much activity, so it's not going to really trigger the alert, but we're going to generate a workload for that anyway. I'm going to go ahead and click on next. For the actions, now you see here I can create an action group. It will pre-populate the subscription and the resource group and the region that this action group can be used in. I'm going to leave it here as global. And then you have to set the action group name. I'm going to say something like DBA group. Go ahead and click on notifications. And then you can decide whether you want to email whoever holds the Azure Resource Manager role, or you can set specific email addresses by selecting here email, SMS message, push or voice notifications. I'm going to go ahead and click there, email, and I'm going to set my email address here, and just go ahead and click on OK. And I have to give this notification a name. I'm just going to set it the same thing, just call it email. Then we're going to go ahead and click on actions. Now here, actions allows you to select other things that happen when your alert is triggered, usually used for other integrations. So you can trigger an automatic runbook, Azure Function, an Event Hub, and so on. In our case, we're not going to use that. We are not going to use any tags to tag the action group. And now we just need to review the configuration, then go ahead and click on Create. Now the action group has been successfully created. We can look at the details of the alert rule. In this case, I'm going to switch the severity from informational to a warning. I want it to give me a warning when that CPU percentage goes over 60, and I have to give the alert rule a name. In this case, I'm just going to call it high CPU. And go ahead. Next, tags. I'm not going to add any tags to the alert rule. Next, go ahead, review and create. You get the summary of all the different options. and go ahead and click on create. Now the alert rule is created, and it might take a few minutes for it to show in the portal. However, we can go ahead and click on alerts, and you get a dashboard here of the alerts that have been triggered by this particular resource. As you can see, I have a couple of alerts that were triggered already earlier, and if I go to alert rules, we can see the active alert rules that we have right now. And you can see we have here that high CPU alert that we just created, and the status is enabled. Now, let's go back to the dashboard view, and let's create a very similar alert, but this time with the PowerShell. So I'm gonna go ahead and open the Cloud Shell. Now I'm gonna bring over the script, and we will run it side by side with the Cloud Shell. The script is part of the download package and is called PowerShell Alert. First, we're going to define the variables that we need for the script, in this case the resource group name, the server name, database name, a rule name that we have to set, and the email address that we're going to use to send our alert notifications. Go ahead and copy all those variables over to the PowerShell. Next, what we're going to do is set the subscription, in this case the subscription that I want, because I have multiple ones, so I have to set the Azure context to the subscription that I want to use for the demo. So I set myself in the right subscription, and now this is where we look at the real alerting code. So first we have to create the condition for the alert. This is done with this commandlet called AZ metric alert rule v2 criteria. We set the metric name to CPU %, operator greater than, threshold 60, and the aggregation to be average. Go ahead and click on that. Copy paste it over to the PowerShell. And now we have a condition object created. Next, we're going to create another new action group just to show how action groups are created on the PowerShell as well. So we're saying we have a new action group receiver. This is an email action, and we pass in the email address as well. Go ahead and bring that over to the Cloud Shell too. And now we have to create a new action group. In this case, the name is going to be DBA group. We pass in the resource group name, a short name, and the receiver object that we just created. Bring that over again to the PowerShell as well. And now we put all that together to create the actual alert rule. Using the commandlet add AZ metric alert rule v2, we have to pass in the rule name, the resource group name, the window size, and the frequency. This is the time window and the time frequency, in this case set to 1 minute. Then you have to pass in the target resource ID. Make sure you replace here the subscription ID with the subscription ID of your particular subscription. Then we set a description for the actual alert rule. We set the condition. We set the action group ID and the severity of 2, which is a warning. Go ahead and bring that over to the PowerShell as well. And this is the last step to have the alert rule created all through PowerShell. Alright, that's done. So let's get back to the portal and see if we can find both of our alerts in the SQL Database Alerts page. Okay, so I'm back here in the Alerts dashboard of AdventureWorks LT Database. If I go over to Alert Rules, we can see we have that new alert high database CPU that we just created with the PowerShell. It's exactly the same alert that we created with the portal, except it was done through the PowerShell code, and they're both enabled. So let's go ahead and trigger some alerts and see what the notifications look like. To do that, I'm going to use same tool I've used before in this course, which is SQL Query Stress. So on SQL Query Stress, I have this particular query that I'm going to be using to generate a workload against the database. The query is also part of the download package, and I'm using 400 iterations and 200 threads to create enough of a workload. I'm going to press go, and this is going to start to run against the database, and then we're going to fast forward because it's going to take a few minutes to run so that we can make sure that an alert is generated. Okay, so the workload has finished. It took about 4 minutes to complete, and now I'm going to show you what the notification looks like. So this is what I received on my email account. It said activated severity 2, high database CPU. Your Azure Monitor alert was triggered. It gives you the timestamp, the alert rule description, the rule ID, the resource ID. It says alert activated because, and it gives you the metric name, metric namespace, in this case the name of the database, the Microsoft resource ID, the time aggregation, the period, the value, operator threshold. So everything that you need to understand what exactly was the metric that generated the alert, you will receive that through your email. Of course, if you sign up for any of the other notification methods, this is the same type of information that you will receive. And at this point, you could then log into your database or into the Azure portal and start your troubleshooting. In summary, in this lesson, we learned about metrics in the Azure portal, the different categories they are separated in, the different aggregations that are available, and the different time frames that you can use to analyze them. Then we looked at creating an alert in the portal, which is a step-by-step GUI-based approach that is very easy to follow. And we also created an alert with PowerShell. And once again, we used the Cloud Shell to run our script full of Azure PowerShell commandlets. And we tested the alert by generating a workload with SQL query stress that triggered the alert and sent it to our email inbox. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello, Cloud Gurus, and welcome to our next lesson, Performance System Views. In this lesson, we are going to look at the views available to track performance in Azure SQL Database. We're going to look at how you can use them and interpret them in the DTU versus the vCore model. Then we're going to look at the different scopes available for some of these views, and we'll do a lesson summary at the end. There are two main categories of performance views in Azure SQL Database. We have the ones that track the resource usage and the ones that track the weight statistics. The resource usage views track resources such as the CPU, data file and log operations, and how much memory you are consuming. DTU consumption plays a factor in how to interpret the numbers. For example, let's say you have a standard 0 database, which equals 10 DTUs, and you get a measurement of 70% CPU. In that case, this means that you're using 70% of the CPU power of those 10 DTUs. It's not really a complete measure if you ignore the DTU value. And if you are comparing to past baselines or other databases, you have to make sure that you are comparing to the same DTU levels. The percentage consumed of your DTUs is also equal to the maximum percentage level of CPU, data, or log capacity that you are consuming. So for example, let's say we're back again with our standard 0 database with 10 DTUs, and we have 70% CPU, 85% of data I/O, and 30% of log write. In this scenario, your actual DTU consumption will also be 85%, since that is the maximum of the three main DTU consumers. And once any resource reaches 100%, you will experience throttling of resources through Azure and your performance will degrade. vCore consumption, on the other hand, is very straightforward. Let's say you allocate 4 vCores and you have a 70% CPU measurement. Well, this just simply means that you are using 70% of the CPU power of the 4 vCores. And you don't have to take into account the added performance unit like you do with the DTUs. Similarly, in the vCore model, all the resource percentages that are tracked, they are independent and do not affect a main performance percentage number like it does with the DTUs. Resource tracking views include sys.resourceStats and sys.dmdb resource stats. Sys.resourceStats is on the server scope. It exists in the master database. It measures in 5-minute intervals, and it retains 14 days of history, and it captures when resource usage changes. If there's no resource consumption, then there is no record written. sysdmdb resource stats, on the other hand, exists at the database scope. and it measures in 15-second intervals. So it has a much higher granularity compared to sys.resource-stats. It retains only 1 hour of history though, and it does capture events even with no activity, so you will have records written even if all the measurements are 0. Weight statistics views exist also on different scopes. You can use sysdmdb weight stats to view the weight types and their statistics inside each database. There's also a sysdm OS weight stats at the server level. However, it doesn't offer much insight because the weights are not related to your database workload, and instead they're more related to Microsoft's operation of the Azure service. In summary, in this lesson we learn about the types of performance views available, which are resource usage or weight statistics. Then we looked at resource tracking percentages, how they change for the DTU and the vCore model, and we looked at the difference in views with different scope between sys.resource-stats or sysdmdb resource stats, as well as the weight statistics views, some of them at the server scope, some of them at the database scope. We looked at the different retention policies. Some of them keep the data for 14 days, the other one keeps it for only 1 hour. And then they also have different time slices with 5-minute intervals at the server level and 15-second intervals at the database level. That's it for this lesson. Thank you for joining me. I'll see you on the next one. Hello Cloud Gurus and welcome to our next lesson. This is a demo of tracking performance with system views. In this lesson, we're going to look at the contents of the views at the different scopes, both at the database and the server level. We're going to generate a workload using SQL Query Stress. Then we're going to track the impact of that workload through the views, and we'll do a lesson summary at the end. Okay, I'm in Management Studio, and this script right here is going to be in the download package for this lesson as well. It's called performanceviews.sql, and the first thing we're going to do is look at the database scope DMDB resource stats view at the AdventureWorks LT database. Gonna go ahead and run that. And we can see here this particular view. First of all, the timestamps are very frequent right after the other. It's always at the top of the minute, then at the 15-second, 30-second, and 45 seconds mark. So every 15 seconds, it is grabbing a screenshot of the metric consumption of the database. And we can see here average CPU percent, data IO, log write, and so on. And also, interestingly, we have the DTU limit column, which in the case of this database is null, because this is a vCore based database. It is not a DTU based database. Now if I scroll back down, for example, in this particular database, we will be able to find here the actual workload that we ran in the previous demo. So you see here the average CPU percent was tapped at 99% for a few minutes, while we didn't consume any data or any log write, because the workload that we ran in the previous demo was all select statements. Now, let's see what happens if we go ahead, switch back to SQL Query Stress and run a different type of workload. Okay, so I'm in SQL Query Stress, and all we're doing here is doing a select into a temp table from one of the tables in AdventureWorks LT, and then updating that particular table. And the intent is to generate log IO so that we can see in the views how it records the difference in workload this time, that is an IO bound workload and not a CPU bound workload. So let's go ahead and run that. And this particular workload took about 41 seconds to run. Now let's switch back into Management Studio and see what the views are gonna say. So back in Management Studio, the first thing we're gonna do is rerun that query for DMDB resource stats. And we can see here right away, as soon as that workload started, we can see the change in the average CPU percentage. We can see a very small spike in the data IO, but we can see here quite a bit more activity in the log write percentage. And we can even see also as well a small rise in the average memory usage percentage as well. And then we can see as well how it goes back to 0 after the workload has completed. Similarly, if we look at the weight stats for that particular database, then we can see the top weight being page latch EX, which means the update latch for that temporary table. Then we see the SOS scheduler yield because we're consuming all the CPU. And also on the third spot, we can see the shared mode latch as well. And this is all due to the update heavy workload that we ran. So these are very specific to the workload of the database, which is what we want. Now let's move over to the master database so that we can see what we collect at the server level. First, if you look at sys.resource_stats, the first thing to notice here is that the time ranges are very different. They're not separated by 15 seconds. They're separated usually by 5 minutes or more. And you see we have different databases, like the databases that we used previously in the course, like T1 and T2. They have been recorded and the history is kept for a lot longer. Now I'm going to scroll all the way down to the bottom, and we see here we have the AdventureWorks LT database, and it also captures the average CPU percentages, the average data I/O, the average log write, and so on. Now the numbers are not going to be exactly the same because the database level view is capturing at the 15-second granularity, and in comparison, this particular view is capturing with differences of around 5 minutes each. So the longer time ranges will usually make the average values smaller unless the value is kept for at least 5 minutes at the same or above level. Finally, what I want to show you is the contents of the DMOS weight stats view at the server level so that you do not use them. I'm going to go ahead and run this query, and you'll see here what we get: SOS work dispatcher, the HADR work queue. These are all related to the actual functioning of the Azure SQL Fabric that services the databases, and it's not going to be really useful for actual troubleshooting. If you are looking at doing performance tuning and troubleshooting of the specific workload, stick with the sysdm-db resource stats view and the sysdm-db weight stats view, as those will give you higher granularity for the metrics captured and the actual weight stats that are generated by your database workload. In summary, in this lesson we looked at the views in different scope, both at the resource usage views as well as the weight statistics views. We also generated a workload, which we did using SQL query stress to consume I/O resources, and then we tracked the impact of that workload on the views, and we were able to go over the resource measurements recorded on the views. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson, Azure Performance Tools. In this lesson, we're going to look at the tools available in Azure to track the performance of your database. Then we're going to look at the troubleshooting methodology that you can follow with these tools, and we will do a lesson summary at the end. Azure has 3 different available tools to track the performance of your Azure SQL database. You have the Performance Recommendations tool, you have the Query Performance Insights, and you have Automatic Tuning. Query Store is a feature of SQL Server and Azure SQL Database that needs to be enabled on the database so that Azure can use that information for recommendations. If you disable Query Store, then you will not be able to leverage the tools that we are covering in this lesson. The first available tool is the Performance Recommendations, and the next one is the Query Performance Insights, and they are very much related to each other. Performance Recommendations gives you actions that are recommended and the expected impact of those actions, and it keeps track of the recommendations that you have applied. Query Performance Insights keeps track of resource-consuming queries, long-running queries, and also allows you to specify custom tracking criteria for some queries that you might be interested in. Automatic tuning is a very cool feature that makes your life as a DBA easier. You can automatically create and drop indexes based on your queries, and you can automatically go to a previous version of an execution plan if Azure detects that the current version is actually slower than the previous one. With these tools available, your troubleshooting methodology can be the following. If you detect a performance issue, then first thing to check is that if you have any sort of resource limitations, whether it is at the CPU, I/O, or memory level. If you do have some, then you can easily adjust the resources or try to decrease the consumption by optimizing, maybe rewriting a query or introducing a new index. After you do any change, measure the performance again, and your problem might be solved. However, if another performance issue is detected, and this time there's no resource limitations, then you can actually look to see if it's an individual query issue by using some of the tools in the portal like the Query Performance Insights. If it is an individual query that is being really slow, then you can check for the recommendations in the Performance Recommendations section, or you can do your own analysis as a DBA by looking at the execution plan and trying to track and debug where the slowness is coming from. After doing any sort of change, you have to go back, measure the performance again, and hopefully your performance issue will be solved at this point. In summary, in this lesson, we looked at the available performance tools such as Performance Recommendations, Query Performance Insights, and Automatic Tuning. Then we looked at Automatic Tuning, how it can automatically create and drop indexes, how it can automatically force a different, better plan, and we looked at the troubleshooting methodology that we can follow with the tools available in Azure SQL Database, such that we can follow a step-by-step approach to debug performance issues and take advantage of all the information that is available in the Azure portal. And at the end of the day, this is where you can leverage a lot of your DBA experience by following an approach that is similar to the SQL Server approach of first looking at the general performance and then looking at the individual query performance. That's it for this lesson. Thank you for joining me, and I'll see you on the next one. Hello Cloud Gurus, and welcome to our next lesson. This is a demo of reviewing performance and recommendations in the portal. In this lesson, we're going to generate a workload with SQL Query Stress, and then we're going to look at the portal performance sections and what it tells us about that particular workload. Then we're going to look at how you adjust automatic tuning settings if you want to change them, and we'll do a lesson summary at the end. Okay, I have on the screen the SQL Query Stress configuration that I used to generate some recommendations for the AdventureWorks LT database. The query for this particular workload is going to be included in the download for this lesson. I used 100,000 iterations and 30 threads for this particular test. It ran for several hours for a few days so that Azure SQL Database would recognize the opportunity here to suggest some recommendations to improve this workload. So if you want to reproduce this on your own environment, just remember you have to run it for several hours and you have to run it for a couple of days before you will see anything show up in the portal. With that out of the way, let's go check out in the portal all the information that we get to describe our workload and tune it. I'm back here in the Azure portal for the AdventureWorks LT page, and to find all the performance related information, just scroll down here on the left hand panel to where it says Intelligent Performance, and we're going to start here with just the performance overview page. This is a dashboard that shows a summary of the more detailed sections that we mentioned in the slides and that we are going to see right now here in the demo. So you see here where it gives you a summary of how many recommendations you have available, whether any of them are in progress, and the summary of your automatic tuning settings. As well, you can scroll down here and it gives you just right away top 3 queries by CPU consumption with some aggregation. You can always scroll here at the bottom and you see there's different percentages that are displayed here in the charts. Now, let's look at these sections in detail. So first, let's look at performance recommendations. So performance recommendations is split into two sections. The top section here, where it says recommendations, gives you an action, the description, and the impact. And then the bottom section will give you a history of the recommendations that you have applied, their status, and you will keep it there as a history of what changes you've done in your database based on these recommendations. If you click on a recommendation, you will get here more of a detailed view of that particular recommendation, the estimated impact, the disk space needed, and it will also give you all the details about the actual configuration of the index, the name of the index that will be created, the type, the schema, the table, the key columns, and the included columns as well. If you don't want to go ahead and create it through the portal, you can also just go ahead and say view script. At this point, you could copy paste it over to Management Studio, or you could save it if you wanted to. Easier to do though is to just simply apply it right away through the portal, and then that will be saved as an applied recommendation in the portal tuning history. So let's go ahead and do that. Click here on apply, and it says the database advisor will start the process to create it and validate it. Do you want to continue? Now it also gives you the option here to automatically apply create index in the future. This is one of the automatic tuning settings. However, I'm not gonna enable it here. I'm gonna show you later where you enable it in the proper automatic tuning section. Just go ahead and click on OK for now. And now we're back here to the main page of the recommendations, and you see here at the bottom now in tuning history, gives us the action that we're applying, and it gives us the status that it is pending, it is being applied right now, and the timestamp of when it was applied. Alright, now let's move on to Query Performance Insight. Now in Query Performance Insight, you have different options that you can see at the top, the different tabs, to have resource consuming queries, long running queries, or some kind of custom criteria that you want to track. So here, for example, we can see top 3 queries by CPU, data, log IO, and we can customize the different criteria here, whether it's the query aggregation, it's a sum, the time period, or the metrics aggregation. You can see here I have a workload, and you can see here the queries that were identified as the main consumers. I can click on one of these as well, and then this will zoom in to the different type of queries at the bottom. Now this is just the last 24 hours. I can go further in time here and say in the past week, for example. Press go, and then we get here a little bit more information. I'll pick that big red one, and we see here this particular query, for example, has consumed 0.77% of our CPU, and accumulated time has been almost 1 hour, 57 minutes of accumulated runtime. And you can actually go ahead and click on these as well, which is very nice, and you get the text of this exact query, as well as the details in its behavior in terms of CPU, data, and log IO, as well as its different duration and execution count. And you can even go see here in the timestamp table, you see here from 224 to 225, so February 24 to February 25, the amount of CPU percentage that this query consumed, the duration, and the execution count. So it also gives you the information of when exactly this query was impacting your workload. So we'll go ahead and go back to the top. You can click here on settings, and that way you can change the visualization for that particular query. And if you go here to recommendations, you just go back to that main recommendations page. Go back to the query details, back to Query Performance Insight, and here, once again, just scroll back up to the top, and then you have the option of seeing the long-running queries instead. Very similar methodology as we just saw with the resource-consuming queries, and you also have the opportunity here to set up a custom criteria by changing the different metrics, whether it's CPU, data log, duration, or execution count, how many queries you want to see, the amount of the time period that you want to look back, the aggregation, and so on. And the same thing, you're just going to get a refreshed chart, and then you'll be able to select the detailed query at the bottom. Now finally, the last thing to look at here is the automatic tuning. So let's go ahead and click on that. And here in the automatic tuning page, you will see how we have three options: force plan, create index, or drop the index, and whether we want to have it an on, off, or that inherit setting. The inherit setting basically says whether you're going to inherit from the server configuration or from the Azure defaults, or do not inherit these settings at all. Now in my case, you can see here it is inheriting from the server. So I can go back, change the setting at the server level, and it will cascade down to this particular database. Now this depends on what you want to do. If you have a database that you want to control a lot more closer, then you can just enable this specifically for this database and disable the inheritance completely. That depends on what you want to do as a DBA. If you have a lot of databases, then I recommend it's just easier to manage it at the server level and to leave the setting to be inherited from the server. In summary, in this lesson we generated a workload using SQL query stress to generate some recommendations and some activity. Then we looked at the performance sections, both at the recommendations, the query insights, as well as the automatic tuning. And then we saw how that can be adjusted through the portal and how that can also inherit the parent settings in case you want to manage it at the server scope level. Thanks for joining me on this lesson. I'll see you on the next one. Hello Cloud Gurus, and welcome to our section summary. In the first lesson, Azure Metrics Alerts, we looked at the monitoring basics, how it's still a DBA responsibility that you need to take care of, how there's different monitoring sources such as resource health, logs, or metrics. And then we looked at the metrics, how we have connectivity, performance, and database usage metrics. Then we looked at alerting. We looked at the signals that can be generated with a database, how these signals get applied against a condition, and when that condition is met, an alert is triggered based on a configuration of an action group. Then we looked at the step-by-step process of creating an alert. In the next lesson, we did a demo of creating database alerts. We looked at the metrics in the Azure portal, the different categories, aggregations, and timeframes available to observe those metrics. Then we created an alert in the portal with a step-by-step GUI approach. Then we created an alert with PowerShell using the Cloud Shell to run our script. And then we tested the alert and used SQL query stress to trigger the alert and looked at the contents that were delivered to our email inbox. In the next lesson, performance system views, we looked at the different types of performance views, which are resource usage and weight statistics views. Then we looked at the resource tracking percentages and how it behaves differently depending on whether you're using the DTU model or the vCore model. Then we looked at the difference in views. Some of them have a difference in scope between database and server, they have different retention policies, and they have different time slices that they track in each individual record inside the view. Then we did a demo of tracking performance with system views. We looked at the views in different scope, we looked at the resource usage views as well as the weight statistics views. Then we generated a workload by using SQL query stress to consume I/O resources, and then we tracked the impact of that workload on the views, and we're able to go over the resource measurements recorded on the views for that particular workload. Then we looked at Azure Performance Tools. We discussed the available performance tools, including the performance recommendations, the query performance insights, and the automatic tuning. We discussed automatic tuning and how it can automatically create and drop indexes based on your workload, and how it can automatically force a different, better plan by using the query store feature. Then we looked at the troubleshooting methodology, which is a step-by-step approach to debug performance issues, and how you can really leverage your SQL Server DBA experience since the approach is very similar. Then on the next section, we did a demo of reviewing performance and recommendations in the portal. Once again, we generated a workload and we used SQL Query Stress to generate some recommendations. Then we looked at the performance sections, starting with the recommendations, then looked at the query insights and the automatic tuning. We also saw how you can adjust the automatic tuning through the portal and how these settings can be inherited from our parent in case you want to manage them at the server level. Join me on the next lesson as we come to the end of this journey with our course summary. Hello Cloud Gurus, and welcome to our course summary, where we will cover the main topics and ideas that we covered in each section of the course. In the first section, what is Azure SQL Database? We learn about the basic service concepts like database as a service, fully managed, and about the elasticity that cloud computing can provide to a database service. Then we talked about the service cost and value, and how the billing is divided between the compute and the storage cost, and the value proposition of freeing up your DBA time to focus more on business and data problems and less on infrastructure management. Then we looked at getting started and what it takes to create your very first database, to select a region, to create a server, and to set up connectivity. And then we actually did a demo of creating an Azure SQL database with the Portal GUI and also with the Azure PowerShell. In the next section, connecting and managing Azure SQL Database, we looked at the different options for networking and firewalls in the service, including public endpoints, service endpoints, private endpoints, the server level firewall, and the database level firewall as well. Then we looked at service authentication, how you can use Azure Active Directory, SQL authentication, or enable both. Then we looked at some of the security features inside Azure SQL Database, such as auditing and some really cool security features that work really well in the cloud, like always encrypted with secure enclaves. Then we looked at some differences with SQL Server in terms of management, such as the different level of access that you get in Azure SQL Database compared to being a sysadmin of your own SQL Server, and some differences in the management views as well. The next section, understanding the service tiers, was all about looking at the DTU versus the vCore model. We looked at the vCore model and how it can be provisioned in a serverless mode versus provision mode, and when one is a better fit than the other. Then we also looked at Hyperscale, which uses a brand new architecture for SQL Server, very different than the architecture that it has on premises, so that it can handle large database sizes up to 100 terabytes. Then we also discussed Elastic Pools, a way to share resources amongst your databases that will really give you a bang for your buck if you are deploying a lot of databases that are not active 24/7. In the next section, recovery in Azure SQL Database, we looked at the automatic backups and how Microsoft runs them. We looked at their schedule, their configuration, and how you can also tune those settings to match your SLAs. Then we looked at short and long-term retention, the difference in both in terms of the default policies, and how you can adjust the long-term retention parameters to get the exact policy that you need for your business recovery requirements. Then we looked at high availability and disaster recovery. We looked at the high availability architectures that are built into the service, which are different in general purpose and on business critical, as well as standard and premium in the DTU model. And we looked at some really cool disaster recovery options like geo-replication around the world. Then finally, we looked at the very cool feature of auto failover groups that allow you to failover groups of databases as a unit and provide transparent client redirection as well. In the next section, migrating to and from Azure SQL Database, we looked at the migration methodology that you can follow to execute a project where you need to move a SQL Server database into Azure SQL Database. Then we looked at the migration tools that are available to do this type of project, which include the Microsoft Data Migration Assistant, the Azure Database Migration Service, Azure Data Studio SQL Migration Extension, and SQL Server Transactional Replication. Then we looked at some other reasons you might want to move back from Azure SQL Database into SQL Server, whether it's due to some service limitations or some features that you might be missing. And we looked at the tools to move back, which could be the export of the Azure SQL Database into a backpack and then importing that backpack into SQL Server, or some other more custom measure like creating an ETL package to move the schema and the data between one and the other. Finally, we looked at monitoring and tuning Azure SQL Database. We started by looking at the metrics and alerts that Azure gathers about your database and how you can customize the alerts so you only get alerted by the conditions that really impact the operation of your service. Then we looked at the performance system views, which allow us to track the resources that are used by the service, as well as the weight statistics that the database is producing as part of a workload. And we looked at the different scope in the views between server level and database level as well. Then we looked at the portal performance tools, which include the performance recommendations, the query performance insights, and automatic tuning. And then finally, we looked at how automatic tuning can be adjusted so that the settings are handled at the database level, at the server level, or at global Azure default level. And so we come to the end of this journey as we look at our last lesson, the conclusion of the course, and what's next, some suggestions for you to continue learning and growing your expertise in the cloud database space. I'll see you there. Hello Cloud Gurus, and let me be the first to congratulate you on completing our Managing Azure SQL Database for the SQL Server DBA course. At this point, you have solid foundation of the benefits, features, and tools that you can leverage when using Azure SQL Database. As next steps, you can continue building your Azure knowledge with courses focused not only on Azure SQL Database, but also other Azure Cloud Database services, like Azure SQL Managed Instance, Cosmos DB, or Synapse Analytics. ACG has some great material, for example, the Using Microsoft Azure Database Services course, or the Azure Cosmos DB Deep Dive course as well. Feel free to reach out for questions or feedback through the course discussion or directly through my social media or LinkedIn profile as well. Finally, the cloud and databases space is a wonderful area to grow in your professional development, and I encourage you to continue learning and developing your skills. Until next time, thanks for watching.